In this video, we are going to learn about some libraries of Python that are very essential for data science. So these are the 7 major libraries that you should know while performing data science using Python. Note that this list is not at all exhaustive, and in practice you will actually need and use a couple of more libraries when doing data science with Python. But these 7 libraries are the most common, and I can say that they are the bare minimum that you need to know. So let's understand what each of the library does one by one. So the first library is NumPy. Now NumPy has very useful features like it lets you create n-dimensional arrays in a very efficient manner. So this is basically how you represent data in the computer's memory in Python. Apart from that, you can use NumPy to perform linear algebra, and NumPy also has capabilities to generate random numbers and random values. The next library is Scipy. Now as the name suggests, Scipy stands for Scientific Python. So it has all the scientific computing tools that you would need to perform certain tasks in Python. So tasks like calculus, signal processing, fast Fourier transform, etc. Now when you talk about data science, you definitely are going to talk about data from multiple files and from multiple sources like CSV, JSON, Excel, so on. And when you are talking about taking these data, what do? You have to read this data which are in multiple formats. You also have to perform certain manipulations or make changes in the dataset itself, and you have to perform certain cleaning operations. For example, there might be some missing value, there might be some random values, so on. So all of these tasks can be done using the Pandas library in Python. After Pandas, the next most important library is Matplotlib. Now Matplotlib is like a fundamental library when you want to visualize data in Python. So all the charts, bar charts, scatter plots, so on, you can build all of them easily using Matplotlib. Apart from Matplotlib, we have another library which is Seaborn. And Seaborn is a library that is essentially built on top of Matplotlib. What it basically does is it has already written smart functions that let you create very beautiful visualizations very easily with less amount of code. The next library is Statsmodels. As the name suggests, this library lets you create statistical models like, for example, regression, and you can conduct statistical tests like t-test, so on, ANOVA, and statistical data exploration. Last but not the least, the next library is Scikit-learn. Scikit-learn is a library that is essentially used for performing machine learning modeling in Python. Apart from machine learning modeling, it also has certain functions that let you perform data pre-processing. So these are the 7 important libraries that you need in order to perform any data science task in Python. Now that you know which libraries are important, the next obvious question is, how can you install them on your system? Well, the good news is, because we are using Anaconda to install Python in this course, we already have some of these libraries in our system. First of all, as we know, we are using Python 3 version in our course. This is because it's the latest version of Python, and also Python 2 is no longer supported. Next, as you can see, libraries like NumPy, Scipy, Pandas, Matplotlib, Scikit-learn, etc. are some of the libraries that we have already discussed that they're important for data science, and these libraries already come with Anaconda installation. So we actually don't need to install them explicitly. Let's try to see this in a live example. We'll try to install NumPy on our system. Let's go to terminal. So this is my terminal, and as you know, in order to install NumPy, we need to have a certain command. Let's see what is that command. You remember we were talking about Python package exchange a couple of videos ago. So now that we know that we need to install NumPy, I'll just search NumPy here. So this is the version of NumPy that is the latest, and this is the command to install NumPy. So I'll just copy paste this command. So I've copied it. I'll go back to my terminal and I'll just paste this command here. Let's see what happens. As you can see, the output of the command is requirement is already satisfied. That means NumPy is already there in my system. And where is it? It is inside the Anacondas directory. So as you know, because Anaconda already has a couple of data science libraries like these installed into the system, we don't need to install them explicitly. In this video, we are going to learn about NumPy. and this is the first library that we will see. Now let's quickly switch to the code window. So NumPy, as we have already discussed, is a very fundamental package when you want to do scientific computing in Python. It provides a bunch of features. Some of the useful ones are it provides an n-dimensional array object, which is really efficient, provides the operational broadcasting. It lets you do linear algebra, Fourier transform, random number capabilities, and much more. So we already know how to install a library in Python using the Python package index. So I'm not going to cover that in this video. But suppose you want to check whether your system has a package installed or not. The first thing that you can do is you can literally try to import the package. If it works, that means the system has the package installed. If it does not, or if it gives you an error, that means you need to install that package. So in this case, I run import numpy as np, and I'm not getting any error. That means this package is installed on my system. Now this way of importing by using as and giving an alias is actually very useful when you're working with a lot of libraries in Python. Suppose you have to use numpy again and again all over your program, right? So it would be difficult to write the entire name numpy again and again, and there are even packages that have names longer than this. So using this as keyword, you can give a alias to any library that you import in Python. So wherever you need to write numpy, you can just write np, and you can call the functions using np dot this. Straightforward. So now that we know that NumPy is installed, let's first of all check the version of NumPy on our system. So we have 1.17.1 installed. Make sure that you also have the same version so that there is no issues in the API of the library. We'll give the command to install this version right below the video. So first of all, as we have seen again and again, that NumPy gives you an n-dimensional array object. So how can you create an array? You can just do np.array function, pass the list, and if you run this, you'll get an array. Now you might be wondering that this data structure looks very similar to a list. Then what is the difference? So this is a list. Let me just create it, and I'll just try to create a similar array. So I'll just copy this and I'll say np.array. Now, do you see any difference between the data types of elements in this list and in this array? So in this list, we had numbers 1, 4, 5. We had a character, alphanumeric character 2, and we had a boolean false. So finally, when we created the list, all of the data types retained the original data types. But in an array, what happened was all of the data types were converted to string. So basically, one of the major differences between a list and an array is an array has this limit that you can only have elements of the same data type. If you have elements of different data type, it will just try to convert them to the same data type. So this is the first major difference between a list and an array. This is what we are showing here also. It basically uses typecasting and upcasts every other data type to string type. Now there is another major difference. So let's see that. You have this list, sample list. Let's just print it. So this is the list. Now what will happen if you multiply the entire list by 2? Let's see. So it has basically duplicated the list, and the entire list is once again appended to the original list. So 126, 126. If we say do it by 3, it will do the same thing 3 times and so on. You get the idea. Now we'll create an array. So this is my sample numpy array. In fact, I'll just remove the print statement so that you can see the array in its raw form. So this is the array. Now what will happen if I do the same multiply by 2 here? So do you see any difference between what happened here and what happened here? Basically, here the entire list or array is not duplicated. It's actually the number 2 has been multiplied to every individual element of the array. So this was the array 1 to 6, and the final array becomes 2 to 12. If you do 3, it will do the same thing. So this is another major difference between a list and an array. An array has a concept which is known as broadcasting. What broadcasting essentially does is, you do any operation on the array, that operation will get implemented on each element of that array. So instead of into 3, you can just say plus 3. So this is the number 1, 2, 3, 4, 5, 6, and each number has been added with 3. You can divide by 3, and you get the idea. So these are the two major differences between a list and an array. And in the upcoming videos of the course, you'll actually understand why this concept of broadcasting is very useful for data science. The next thing that we are going to talk about is how to create a matrix in NumPy. So as you know, NumPy is very good for linear algebra. So the fundamental instruments of linear algebra is matrix. So you can create a matrix in NumPy. First of all, I've created this multi-dimensional list A, right? And if you want to create a matrix of this list, you can just say np.array and pass the list. And you get the matrix, which is nothing other than just a multi-dimensional array. Now you can access elements of this matrix just like you would have done for a real matrix. Suppose you want to access this number. So this number is row 0. So row 0 and column 1. So you get 2. If you do column 2, then you will get 3. And you can do it again and again. Now instead of explicitly creating a list and passing it to an array function, you can directly pass the structure in the array function itself in order to create a matrix. So both of these matrices are same. You can also create a matrix that is filled up of random integers using np.random.random function. So 0 to 10 is actually the range in which you want the random numbers to be, and 3, 3 is the shape of the matrix. So if I just increase the range to say 100, you will see that the numbers are 2-digit. Now let me do this back. So notice that even though I'm running the same code with all the same parameters, both the times we are getting matrices with different random values. And that's what the random number generating capabilities of NumPy is, right? But sometimes in real life, you need to be able to predict what kind of random numbers will be there in the matrix. So there is a way to fix this, and that is known as seed. So suppose I've given the seed 0. Now if I call this function, I'll get a bunch of numbers. And if I call this function again with the same seed, I'll still get the same bunch of numbers. So seed lets you fix the behavior of a random generator. Now because seed is 0, anytime you run this cell, you will see that you will get the same matrix. And the minute you remove the seed or change it to some other value, it becomes random. So seed is a way of making sure that no matter how many times you call the random function, you'll get the same numbers. And if you don't give the seed, then you'll have the original behavior, which is every time you call the function, you'll have a matrix of random numbers. Next thing in NumPy is you can actually create an entire matrix that is filled with nothing but zeros. So this is the shape that you give 3, 4. Zeros is the function and you can give the type. So I have this matrix. Another matrix 4 by 5. Similar to 0, you can also create a matrix filled with ones. So you can use the ones function, give the shape of the matrix, and you get the matrices. You also can create an identity matrix. So because identity matrix is a square matrix, you have to give only one number, and I have given 5, so it will create a 5 by 5 identity matrix. You can change this value to 3 and you will get a 3 by 3 identity matrix. Suppose you want to create a matrix that is filled with a specific number. So this is the shape. You want to fill it with 3.14, and you can use the np.full function and you get this matrix. Similarly, this time we have filled the matrix with 7. The next concept that comes to mind is when you want to concatenate or combine two arrays or two matrices. So this is the matrix 1 and this is the matrix 2. And first what we want to do is we want to combine them row wise. So after 4, 5, 6, I want 7, 8, 9 here, then 10, 11, 12 here. So you can do that using np.concatenate. You can pass both the matrices as a list, and you have to give access equal to 0. So whenever you give access is equal to 0, you are telling NumPy to do a row wise operation. See, these two matrices, it combined in a row wise fashion. Suppose you want to do the same thing column wise, then the same code you can use, same concatenate function, same way of passing the matrices, but access should be 1. So whenever you give access equal to 1, you tell NumPy to do a column wise operation. So let's see what happens. So this is a first 1, 2, 3, 4, 5, 6. Now after that, we have added values in column fashion. So 7, 8, 9, 10, 11, 12. So this was basics of NumPy, a very useful library in Python, and we will explore it as and when needed in the course. Let me show you the documentation of NumPy. To come to this page, there are a lot of useful things like tutorial, basics, so on. You can click on NumPy reference. So these are the functions and possibilities that you can do with NumPy. Feel free to explore them and see what are the things that you can directly use in your work. So there are things like discrete Fourier transform and so on. In this video, we are going to learn about another useful library of Python for data science, that is Scipy. So let's go to code. So as the name suggests, Scipy stands for Scientific Python, and it is a library that works very closely with NumPy to give you scientific capabilities in Python. So just like NumPy, first of all, if you want to check if a library is present in Python or not, you try to import it. So in our case, the import works. That means Scipy is there. Now let's check the version of Scipy. So it says that the version of Scipy is 1.3.1, but actually in this course we are looking for a version of Scipy as version of Scipy. So we want 1.4.1 in this course. To fix this issue, what you can do is you can simply create a new cell. So remember I told you initially that you can use exclamation to run commands on the terminal or command prompt. And we also know that you can use command like say pip install Scipy to install Scipy, right? So there's also a trick to this command, which is if you want to install a specific version of Scipy, you can just say pip install Scipy, and you can do the syntax equal to 1.4.1. Let's run this command. So it says collecting Scipy. So now it will take some time because it's downloading this version of Scipy. So now it is uninstalling the old version, and it has successfully installed the new version of Scipy 1.4.1. So let's check the version again. 1 minute. Because we have installed it recently, we need to restart the kernel. So let's restart the kernel. Now let's import Scipy again. This time we don't need to execute this cell because it's already installed. So I'll just comment it out and I'll check the version of Scipy. Now as you can see, we have the exact correct version of Scipy. So this trick is very useful, that you can just use exclamation, then use pip install, then the library name equal to the version you want. And if you want to check what versions there are, then you can always go to the documentation page of library and see what are the versions available. So Scipy gives you a couple of useful features. Some of the common and most useful features are, for example, you can compute the derivative of a function, so you can do differentiation. So this is the function, and the equation we have is x squared plus x plus 1, and you can use the derivative function from the scipy.misc package, and in this function you pass the function and you pass the value of x at which you want to differentiate this. So at x not equal to 2, you know, by high school mathematics, the x squared plus x plus 1 actually becomes 2x plus 1 once you differentiate it. So when you're passing the value of 2, so as you can see, I got this error when I tried to run this line of code. It says name derivative is not defined. Can you guess why this is the case? This is because I did not run this cell before running this cell. So if I have not imported derivative at all, how can I call the derivative function? So let's run this cell before, and when I run this again, I get the output. So this is a silly mistake that you should also be careful of when you're actually programming in Jupyter Notebook. That first you need to import the right libraries, only then you can use them and execute all the cells in the right order. So we get the value of 5, and we know that this is the equation after derivative. This is the f dash x. You put value 2, so it becomes 2 into 2 plus 1, 5. So this works. Similarly, you can calculate the second derivative, and you can do a lot more. So this was derivation using Scipy. Apart from that, you can also calculate permutations and combinations. So 4c2 is 6 and 4p2 is 12 using Scipy. Here we have used the com function, and here we have used the perm function. Then you can also do good amount of linear algebra from Scipy also. So you have to import the linear algebra module from Scipy, which is linalg. We have also imported the NumPy. So using NumPy, we created this matrix, and suppose you want to calculate the determinant of this matrix. So using linalg module, of Scipy, you can use the det function to calculate the determinant of this matrix. This is the determinant. Similarly, you can calculate the inverse of this matrix and you get the idea. So this was Scipy in a nutshell. Let's go to the documentation of Scipy. Select the Scipy reference guide. So these many tasks you can perform using Scipy, things like signal processing, integration, optimization, special functions, interpolation, Fourier transform, and a lot of other stuff. And if you click on one of these things, you can actually go inside and see what are the functions that you have available for each of these tasks. And they've also given pretty good tutorials. So this was Scipy. So Pandas is an open source library in Python that we use a lot for reading data, performing data manipulation and related tasks. So it supports out of the box reading files from different formats like CSV, JSON, Excel, HTML and so on. And these are actually the formats that are very common in the world of data science. We can summarize the data, we can filter and modify the data, we can merge multiple files and so on. So let's have a quick intro of this library. First of all, you import it just like we have done in the case of NumPy. You use a alias PD. So wherever you say PD in the code, Python understands that PD means the pandas library. So we run this. That means we already have pandas on a system because we do not get any error. In case you get any error and you want to install pandas, you can simply use one of the two commands given here. So if you have Anaconda on a system with Python 3, just the way that we had told you to install it in the installation section of this course, then you can just do pip install pandas. But if you have Python 3 and Python 2 multiple versions of Python in your system locally without Anaconda, then you can do pip3 install pandas. Pip3 means Python 3 is pip. So I'll just use this command pip install pandas. So we will run this. Let's see what output we get. So as expected, it totally tells you that the requirement is already satisfied, which is basically you already have pandas in your system. Let's check the version of pandas. So for this course, we are using this version of pandas 0.25.1. So this is pandas. Now let's read a CSV file. So we already have a CSV in our directory. So this is how the CSV looks like. So these are the column names. They're separated by a comma. Then you have value separated by a comma, right? So let's read this CSV in Python. Remember that these were the column names, item identifier, item weight, so on. So using pd.read CSV function, you can just give the path of the CSV file and you will be able to access it. So now your CSV file has been stored in the variable data. First of all, let's see what are the first three rows of this data set. So .head function basically lets you see the initial rows of the data set. 3 means basically first 3 rows. You can convert it to say 20 and you will get the first 20 rows. So this is our data set. These are the columns, multiple columns, and these are the values, all the rows. The next step is you want to understand how many rows and columns are present in the data. So to do that, you can just use the dot shape property. So data dot shape. So we have 8523 rows and 12 columns. Now let's print the name of columns. So data.columns gives you the name of columns. So these are the columns you have: item identifier, item weight, item fact content, visibility, outlet location type, and so on. The next interesting thing is you can also find the data type of the columns of a data set. So as you can see, these are real values 9.3, 5.29. These are string values. So let's see what are the data types of our columns. So data.dtypes is the property that lets you view the data types of the columns. So object essentially means where there is a string. Float64 is again float or real data type. So these columns, item weight and item visibility, are decimals, and item identifier is a string. So let's see, item identifier is a string, item weight and item visibility are decimals. Makes sense, right? Then you have outlet establishment here, which is int. So let's see what is this. So if you see the outlet establishment here, you will see there is no decimal because it's the year. So this was how you can access the data types of columns in pandas. The next thing is, what if you want to know what are the total number of missing values? So you can use data, then use the isNA function, and then use the sum function. This line basically says, first of all, count the total number of values that are missing in each column in data, and sum them up so that you get a total number. Let's see. So the item weight column has 1463 missing values and outlet size has 2410 missing values. Apart from this, no column has missing values. So this is very useful when you want to actually understand that okay, my data might be having missing values. So this is a very useful step during pre-processing. Next thing is you can also calculate or find the summary of the data. So summary is essentially column wise, count, mean, standard deviation, minimum, maximum value. This just gives you a quick overview of the data itself. Notice that it only includes the columns that are numerical. It doesn't include columns that have string type like item identifier because you cannot count the summary for them. So this was basics of Pandas. Pandas has a pretty good documentation and you have things like getting started, user guide, API reference, developer guide and so on. You can choose whatever you need. By default, when you work with Pandas, you usually go to the reference guide. So these are the, for example, different file types that Pandas accepts like SAS, HTML, Excel, so on. And you want to do some manipulation functions. A lot of things are available here and you can select whichever function you need. For example, for plotting or for general utility functions, you can select that function and you will come to know details about how to call that function, what values it returns, some examples. And this is how you can work with Pandas. In this video, we are going to learn about two very important libraries of Python, that is Matplotlib and Seaborn. Now these two libraries are used a lot when you're talking about data visualization. So without waiting much, let's move to code. So first of all, we want to import Matplotlib to see if it's present in our system or not. And as you know, it comes with Anaconda. So this line of code runs without any problem. The version of Matplotlib that we are going to use in this course is 3.1.1. In case your system does not have the same version, you know how to install the right version. Now, we are going to use the PyPlot module of Matplotlib in order to make most of our visualizations. So you can import this PyPlot module and give it the alias PLT. Apart from that, we also write this line, which is %matplotlib inline. This is basically a Jupyter shortcut which helps Matplotlib to make visualizations in the notebook itself. Then we also have the same libraries NumPy and Pandas that we have seen before. So let's import all of them. So using Matplotlib, you can create basic plots like line plot, for example. Then you can also create other basic plots like, for example, bar chart. So this is a stacked bar chart. The orange portion represents the class 1 and the bluish shade represents the class 0. Now this was Matplotlib. Apart from Matplotlib, we have another library that is Seaborn. Seaborn is basically a simpler version of Matplotlib, if said in a very simplistic manner. Seaborn is actually built on top of Matplotlib. So a lot of things that you can do in Matplotlib with say 4 or 5 lines of code, you can actually do them with 1 or 2 lines of code in Seaborn. Apart from that, a lot of good code on how to make beautiful visualizations are already inbuilt in Seaborn. Let's see. So we have created some random data and so this is the density plot of the data. This is how the distribution smoothly looks like. Let's have a histogram. So this is a histogram. Now we can combine both of these and we can have both histogram and density plot in order to give you a better idea of the data. So as you can see, Matplotlib and Seaborn are pretty similar, but Seaborn has different types of plots that you can create by just using very less lines of code. So here is another interesting default that Seaborn provides you. Let's see. So this is known as pair plot and we have this data set where we have so many columns and then this is the target, which is which flower type or which species does these data points belong to. If you use pair plot of Seaborn, what it does is it plots the relationship between all of the variables with every other variable in the data set itself. So multi-dimensional relationship like sepal width with sepal length, then with sepal width, then with petal length, then petal width, so on. And as you can see, all the data points or all the distributions are color coded based on their class. So Setosa, versicolor, virginica, so they are differently color coded. So this was essentially Matplotlib and Seaborn, very useful libraries when you're working with data science in Python. Let's check out the documentations. So I'll first go to Matplotlib. So this is a documentation of Matplotlib. There are lots of tutorials, how to install, and how to create interactive plots and so on. You also have API overview where you can see what are the usage patterns, you have books, links, and you can just go through these examples and documentation and just see what are the things that are available in Matplotlib and explore them more. Right? You have so many examples of visualizations that you can actually create using Matplotlib, and you have gallery. Coming to Seaborn, so this is a documentation of Seaborn. Seaborn actually lets you access different types of visualizations that it provides based on the kind of relationship you want to plot. So they are relational, categorical, distribution, regression, so on. So you can click on the API and see what are the functions available. You can also click on tutorials. So these are the functions that are available, and you can click on any one of these functions like cat plot, which is categorical plotting. You can scroll down and you will see that they have given good amount of examples, and you will be able to see really beautiful visualizations that are quite complex also, that Seaborn is able to create by just using, say, 3 or 4 lines of code. So this was Matplotlib and Seaborn. In this video, we're going to talk about the Scikit-learn library of Python. Now, this library is used a lot for machine learning modeling. Let's go to code. So Scikit-learn helps us do a couple of tasks. The first task is pre-processing the data. So pre-processing involves imputing the missing values, encoding the categorical variables, normalizing the data, and so on. Then you can build different kinds of model like linear regression, classification models like decision tree, and so on. And finally, you can also automate this entire process of taking in the data, pre-processing it, training different models, and making a prediction on them. Let's see one by one. There are 6 main steps to create a machine learning model in Scikit-learn. You can import the model, then you need to prepare the data set, then you need to separate the independent target variables, create an object of the model, fit the model with the data, which basically means train the model, and use the model to predict the target. So I have imported Scikit-learn, and it's already present when you install Anaconda, so we are not getting any error. In case you get any error with the version, you can just run this piece of code. In this course, we need the version 22.1. So the first thing that we do is we just import a data set. As you can see, there are certain values missing in these two columns, item weight and outlet size. So this is where the simple imputer comes into picture. Scikit-learn gives you a functionality using which you can impute these values. So you can just give the column name and you can decide which strategy you want. For example, if it's a numerical column, then you want to replace the missing values by the mean of the column. If it's a categorical column, then you want to replace by the most frequent category in the column. So we just run this piece of code, and finally, after running the above piece of code, you realize that all the missing values of the dataset has been dealt with. Next, you can create regression and classification models in Scikit-learn. It provides a lot of classification regression models, for example, linear regression, decision tree classifier. And you can use the pipeline feature of Scikit-learn to create a pipeline that essentially helps you automate everything from the minute the data comes in, pre-processing the data, building the machine learning models, and making prediction on them. Let's see the documentation of Scikit-learn. So this is a documentation of Scikit-learn. There is classification, you have algorithms like SVM, nearest neighbors, random forest, etc. For regression, you have multiple algorithms. You have clustering, model selection, pre-processing, feature extraction, dimension reduction. So you have a lot of things, and you can just click on one of them and see what classification algorithms you have. So there are multiple such algorithms, and this library performs really well. So this was Scikit-learn in a nutshell. Apart from this, Scikit-learn also comes with a couple of data sets of its own that we'll see in the next video. But machine learning modeling is something that we'll cover in greater depth if you are part of the applied machine learning course. In this video, we're going to learn about Statsmodel in Python. Let's move to code. So Statsmodel is a package in Python using which you can perform statistical modeling like linear regression and so on. Apart from that, you can perform statistical testing. You can also work with time series data and time series techniques and so on. So this is a library that we'll be using further in the course, but for now, let's just have a quick intro of it. So we import it just to see if it's present or not. It is, and the version that we're using in this course is 0.10.1. We import a couple of other libraries and we load our dataset using Scikit-learn's datasets. Let's see how our data set looks like. So we have a bunch of columns, and our target column is MEDV. So this is the target column. We just print the target column also. This is the target column. These are the predictor variables. Now we denote them as X and Y, and we try to build a linear regression model using the OLS method. So worry not if you do not know what OLS is. This is actually a statistical linear regression technique. But for now, you can take the predictions of the model, and after you have trained the model and taken all the predictions, you can just print the summary. So what was the performance of the model, what was the kind of data it had, and so on. So this was Statsmodel in a nutshell. As you can see, you can do a lot of more things like regression linear models, time series analysis. A lot of statistical tools are easily available. So let's go to the documentation. So this is a documentation of Statsmodels, and you have a user guide here, you have a API reference. So you can see time series analysis, other models, statistical and tools, data sets, what kind of data sets it has, optimization. So you have a lot of things that you can do using Statsmodels. Now so far, we have seen the basic introduction of all the Python libraries that are commonly used for performing data science tasks. We also know that there are 5 major tasks of data science that are done using Python. And in this module, we will learn how to do the first task, that is reading data files. So here are the types of data files that we will be working with. CSV, or comma separated values, is one of the most common file types that you usually find when you're working in real world data science situations. The next file type is text. These are essentially any file that have .txt extension to it. Apart from these two, we also have the MS Excel or spreadsheet format that is widely used in the industry. Now JSON is a file type that is heavily involved when you're dealing with data from, say, websites and APIs and so on. If you notice, you will see that out of all these different types of data files, we have already dealt with text files in previous module. So apart from text files, in this module we will learn how can you work with CSV files, Excel files and JSON files in Python. In this video, we will work on CSV files. We'll also understand the challenges that occur while reading CSV files in Python, and also how to tackle these challenges using Python. So once again, you can install Pandas using these two commands, as you already know, based on your system configuration. So as you already know, we'll be using the Pandas library for this task. Now, the first step that we usually do in order to check whether a library is present in Python or not in your local system, we try to import it. So here we are saying import pandas as PD. So this gave us no error. And then we print the version of pandas. In case pandas was not present in the system, this would have given us an error, and we could have used one of these commands to install pandas. Now, the first thing that we're going to do is we'll read a simple CSV file. Let's see how a CSV looks like. So I'll go to the datasets folder. I'll take the Big Mart sales CSV. So this is the CSV that we have. These are the column names, item identifier, item weight, item fat contained. These are the values of them. Everything is separated by a comma. So this is actually a data set that we have taken as a sample data set, and it is the sales data set from a store known as Big Mart. Let's get back to our notebook. So at this point, we already know that if you want to import a CSV in Pandas, you just use pd.read CSV. So let's do that. So the type of data that we have in this variable data is actually data frame type, pandas.core.frame.dataframe. So you can imagine a data frame is a data structure in Python. So you can consider that a data frame is actually a type of data structure that Pandas provides to you in Python. Now data frame has multiple features, like it is two-dimensional and you can have columns of different data types. It is very similar to spreadsheet or a table that you have in SQL, and it is one of the most commonly used data structure in Pandas. Let's see how our data looks like. So this is the data that we read from the CSV, and this structure is known as the data frame. If you go back to the CSV, you will realize the column names are same and the values are similar, like you have FDA15, DRC01. So Even here you have FDA 15 and DRC 01. So this is the same CSV data in the form of a data frame. Now, when we read this data set in Python, as you already know, the first thing that we are curious about is to know how many rows and columns are present in our data. So you can do that using data.shape. So our data set has 8,523 rows and we have 12 columns. So this was a basic way of reading a CSV file in Python using pandas data frame and seeing how many rows and columns are there and what does the data look like. So this is something that we have already covered. Now let's go to some of the challenges that we face when we are reading CSVs in practice. So the first challenge that we will have is in our CSV, we'll actually have the first few rows which are like comment in Python. And we want to avoid reading these rows because these are essentially comment and these do not form the part of the data set. Let me show you what I'm talking about. So I'll open this file, bigmart sales top row error.csv. So notice we have our data set starting from this line. Above this, we have a bunch of comments written by the person who has either created this data set or curated this data set, and this basically tells some general info about the data set. So this is something that you find a lot when you're working with real world data or open source data. People usually add comments describing the data in the file in the initial few lines of the file. Now if you try to read this file by the same way that we had read previously, you'll actually get an error. So we got a parser error and it's like it's not able to tokenize and so on. So in order to prevent this error, you have to basically tell pandas that avoid reading these first couple of lines because this is not where the dataset starts. Start reading from say line number 6. So let's see how can you do that. So in order to do that, there is a parameter in pandas read CSV function which is skip rows. So you can just say how many rows you want to skip of the dataset. So we know that our actual dataset starts at line number 6 or row number 6. So we'll just tell pandas to ignore the first 5 rows. So that's what I have given here. I have said skip rows 5. Now if you run the same code, you will see that the dataset has been loaded without any error. So this was challenge number 1. Now the second challenge that we have when we are dealing with CSV is a lot of times when you're working with say open source data or you have some data from your data engineering team, you will notice that the dataset is actually divided into multiple folders and directories in your system. So you do not have one single CSV, but you might have different CSVs spread across different folders. Let's see what I mean. So I go back to the datasets folder. I have this folder known as multi-directory. If you open this folder, you will see there are multiple subfolders, each with an year as its name, 1985, 1986, 1987, 1998. And when you open each subdirectory, you will see there is a CSV. This CSV is basically sales record for that year. So what has happened is you have received the data in this format where you have sales record of the store divided by year in different directories. Now how can you read this in Python? Let's see. So the first thing that we are going to talk about is the glob library. So glob is essentially a library that you use when you want to read multiple files together in Python. It kind of helps you to automate the process and make it easier. So let's import glob. Then you write this code from directory in glob.glob and you give the path of the directory which is the multi-directory, and then you give star symbol or asterisk symbol. This basically says any folder inside the multi-directory folder. Now let's see how many subfolders does glob detect in this multi-directory folder. So according to glob, these are the subfolders which are correct as we have already seen, and now we also want glob to see how many files or CSVs we have in each of these folders. So initially we had run a single loop for all the subfolders. You can run another loop inside this loop and then use the same method, give the directory path, add /star. So this is basically, so initially we are going inside multi-directory and taking all the folders and looping over them. Now within each folder that we have here in the directory, as you know, this is the directory value at each iteration. Within each folder, we also again look for a /star, which basically says any files that are present inside these folders. So let's see what are the files. So as you know, we have one CSV each in each folder. So now using glob, we have figured out how our dataset looks like in terms of folder structure. What's the next step? So the next step is we'll read all of these files and we'll have to combine all of these CSV into one single CSV, because at the end of the day, all of these CSVs talk about the same store, the sales data of the same store, but for different years. So that's what we have done. We have used the same two loops to iterate over all the subfolders of this multi-directory, and inside each subfolder go through all the files that are present. Then what we do is we read this CSV file, which is basically if you first read the 1985 CSV file, then 1997, and so on. And we keep on appending these CSVs to this list, which is data frame list. So all of these CSV files are first of all read as data frames in Python using pd.readcsv, and we have just made a single list of all of these data frames. So let's run this. Once you run this, you can actually try to access this list and see what it has. So you will see there are multiple data frames in this list. So when you take a length of this entire list, we'll get 9. And how many folders and files we had? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we had 9 files inside 9 different folders, and that's what this list has. It has 9 different data frames. Now that you have all of these data frames as a list, the next thing that you do is you want to combine all of them. To combine these data frames, we use the concat function of pandas. It basically concatenates all of the data frames one below the another. So let's see what happens when you concatenate. So I run this piece of code and I check the head. So as you can see, all of the data frames have been concatenated, and you can also see the shape of this data frame now. So it has the same shape, 8523. So this was challenge number 2, when you're working in real world data setting and you have multiple files, each of which are supposed to be combined to get your entire data set. This is how you can achieve this using glob and the concat functions of pandas. Coming to challenge number 3. Now before we go to challenge number 3, I also want to give you an example of how to save CSVs in Python. So you created this one big CSV of one big data frame, and it's made up of combinations of all those small CSVs. And suppose you want to save this data frame as a CSV for further usage, you can just use data frame's name and then use .toCSV function in pandas. When you use this function, you can give the path, and we give index is equal to false because we do not want this index to be stored inside the CSV. So when you run this line of code, you will notice that this CSV is actually saved in your directory. Let's see. So we have merged Big Mart sales. Let's see. I'll go back to our data sets. I'll scroll down, and this is where we have the merged Big Mart sales CSV. So this is the same CSV that we just saved here. So this is a very useful concept of pandas, which is basically any data manipulation or any changes that you perform on your CSVs, you can actually save them for future use. So the next challenge that we have in front of ourselves is how can you read CSVs that are separated by a specific delimiter. So far, as you have already seen, all our CSVs, the values were separated by a comma, right? So this was the comma, and you could see that this pattern was same. But when you're dealing with real world data, you also see that sometimes a CSV has, apart from comma, some other characters as delimiters. For example, there are files known as tab separated values or TSV. In that case, it is just a CSV, but instead of having a comma, you have tabs separating the values. Let me show you an example. So I'll again go back to the datasets folder, and I'll open this file, Big Mart sales delimiter. So notice that you have tabs separating values. Now this is how Jupyter shows a tab when you are writing a text file. This is essentially the same tab key that you have in your keyboard. When you press that tab key to separate data values in your file, it's a CSV that is delimited, or all the data values separated by a tab. So let's see how can you solve this in Python. So this is the same file with delimiter as tab. If you try to read it using the same normal approach that we had seen before, you will see that it just messes up the entire data. Like the columns are coming randomly, /t is coming, and the values are getting like this. So you can pass a parameter to the pd.readCSV function in pandas saying delimiter is equal to \t. So \t essentially means it's a shortcut or a shorthand for a tab space. So when you do this and then print the same dataset, you will notice that in this case the dataset is actually coming very properly. So compare this with this. So apart from comma and /t, there can be other delimiters based on the kind of format or data you are using. You can just pass that as a delimiter here and pandas will take care of the rest. This was challenge number 3. Let's go to challenge number 4. So challenge number 4 is actually a challenge that I have seen a lot in my day-to-day life, which is a lot of times you are working only on your local system. You're not using any big servers or large servers that have good amount of RAM like 32 GB, 64 GB. In those situations, you will realize that if you're working with data sets that are very large, for example, there's a CSV file that has say 100 million rows. In that case, when you're trying to read that CSV, it either takes a long time for pandas to read it, or sometimes your program might even crash. In those cases, what we try to do is we see the CSV in parts. So what we tell is, okay, instead of seeing the entire 100 million rows, I just want to see the first 100 rows, then next 1000 rows, next 1000 rows, and so on. And this is what the nRows parameter of the read CSV function helps us do. So this is the same BigMart sales CSV that we have seen earlier. We give nRows is equal to 100 as a parameter. We read the file. Now you will see that the number of rows have been fixed to 100. It is no longer the same entire dataset where we had like 8500 plus rows. This is actually a very useful trick that you can apply when you're working with files that are too large to fit into your RAM. If you just see the head of this dataset, it's the same dataset, nothing has changed. Now just like the fact that you can read first n rows in a dataset, you can also read specific columns when opening a file in pandas. So this is very straightforward. When you're opening a file using the read CSV function, just use the parameter use calls and give all the column names that you want to read. When you execute this piece of code, you will see that you're only getting those columns which you have clearly mentioned. So these were some ways in which you can deal with the challenges that you face when you're working with CSV files in pandas. In this video, we will see how can you read Excel files in Python and what are some of the challenges that you face when you're working with Excel data in a real life setting and how can you overcome them. So again, we'll be using pandas to read the Excel files. You know how to install pandas by now. The first thing that we do is we import the pandas library as PD. Now let me show you the Excel that I'm talking about. So this is the same Excel. So this is the same dataset that we saw in CSV form earlier about BigMart. And this time we have it in Excel form. So these are the columns, item MRP, outlet identifier, so on. And you have these rows with values. Let's go back to code. So if you want to read an Excel file in Python, you can just use read Excel function of pandas and give the path to the file. So when we execute this piece of code, you'll see that we have got the same Excel file .xlsx format as a data frame. Now what are the challenges when you're working with Excel files? So the first challenge is dealing with files that have multiple sheets. Now I know all of you who have worked with Excel or spreadsheets before, you know that this is something that happens a lot. A lot of times you have multiple sheets within the same spreadsheet or Excel file. Let's see. So I'll first show you the sheet that I'm talking about. So this is the spreadsheet that I'm talking about. You can see there are multiple sheets like 1985, 1987 and 1997. So basically these are sales data of the same store, but each sheet is for each year. And this is a very common way of organizing your data. Let's see how to load this in Python. So if we use the same code of just using read Excel function and try to print the total data that we have in the spreadsheet, you will realize that we only have data of the first spreadsheet or the 1985 year, which is this. It is the first spreadsheet. So when you're reading Excel data in Python, and suppose you may have a situation where there are multiple sheets within the same spreadsheet, you actually have to tell explicitly to Python which sheet you want to access. Otherwise, it will always access the first sheet. Let's see how to do that. So suppose you want sheet 1985, you can just say sheet name equal to 1985 and just give the name here. So this is a 1985 sheet. You can see that the outlet established year is 1985. Similarly, you can do for 1987, you have the year right, and then you can do 1997. So these are all the 3 sheets that you have in your spreadsheet. And the next thing is, as you would have already guessed, we want to combine all of these data frames from these different sheets into a one big CSV or one big data frame. To do that, we again use the concat function. We first create a list of all these sheets or data frames, and then we use the pandas concat function to create a single CSV. And this single CSV has all the 3 years. So this was challenge number 1. Now challenge number 2 is, just like a CSV, even in an Excel or spreadsheet, you can have first few cells with just comments about the file and its description. Let me show you. So this is a file, and you can see the first few cells just have random comments. Usually there can be comments talking about what this file contains, whether this file is talking about sales data, so on. Now just like we did in CSV, if we do not read this issue, we'll have some random values and data that looks slightly disturbed. So we can use the same skip rows equal to parameter in the read Excel function, and this will help us to read the entire file correctly. Now here is an assignment for you. Remember that we were using glob to read CSV files from multiple directories. So you can use the same glob code, and instead of reading multiple CSV files from different directories, you can actually read multiple Excel files from different directories. And this is an assignment for you. So there is this directory in your datasets folder known as multi-directory Excel. Go to that directory and try to use the same glob code that we saw in CSV, and try to see if you can solve this. I'm pretty sure with the knowledge that you already have, you're going to do this very easily. In this video, we are going to see how can you work with JSON files in Python. First of all, we'll be seeing the pandas library of Python. So let's import that. Now this is how our JSON looks like. It's a pretty common, straightforward JSON. And if you want to read this JSON in pandas, you can just use the read JSON function and give the path and the name of the file. So let's do this. And you get the JSON in the same data frame format that we have seen before for CSVs and Excels. Now, this is a good example of a JSON, but sometimes when you're working with real world data, you'll also see a new format in which JSON is arranged. And that format is this. So the difference between these two files is this entire file represents a single JSON, while in this file each line is actually a separate JSON. So when you're trying to import this file in pandas, you need to be aware of that. Suppose we try to read this file in pandas like the same way we have done before, it will give you an error. The way to work with this kind of file is you use a parameter known as lines equal to true of the read JSON function, and then you won't get any error when you're trying to work with this kind of file. Now, apart from this, another challenge that you see a lot when you're working with industrial data is sometimes you have nested JSONs like this. So inside one JSON, you actually have another JSON. So if you try to read a nested JSON like this in pandas, you will see that it gives an error. And this is where the JSON module of the standard library of Python comes into picture. Now this module is very focused on JSON and provides you a lot of useful features using which you can work with JSON files. So let me import the JSON module, and if you want to read the JSON file, which is nested.json, the basic syntax is same as you would have read a normal text file. We use with open, we give the file name, we say as f. Inside though, instead of using f.read, which is the normal function we use when we were working with text files, here you will say json.load. Using the load function of the JSON module, you can see that you have successfully read the nested JSON file in Python. Let's pretty print this. So pretty print is another module that comes with the Python library. Now this module is very useful when you want to print the data in a structured format. You can read more about pretty print and its documentation here. But for now, using pretty print, we are able to see the structure of a JSON. So you have these different records, and in each record, inside the details field, you also have another JSON which is consisting of age, grade and name. So let's solve a small challenge or a task to understand how to work with nested JSONs better. First of all, what we want to do is, we have this nested JSON where each record has a details section, and within that details section there are records of name of the people, their age and grade. So what we essentially want to do is, we want to go through all of these records in this JSON and only select those records in which the age of the person is greater than 15. So this is one such record, this is not that record, the age is 11 which is less. This is another such record where the age is 22, that is greater than 15. So let's see how can you write code for that. First of all, we know that we have read the entire JSON file in my JSON data variable. And we also know that it's actually a list of multiple JSONs or records. So first of all, let's try to access the first element of the list using the 0 index. So this is how a single element of the list looks like. Now, the first thing that we need to do when we are trying to access the age is to access the details part. So let's say data 0 of details. So this is another JSON. And if you want to access the age, we can just say details age and we get the value. Now we just have to do this same thing in a loop so that we get all the ages of all the records in a data set. So let's run this in a loop and these are the ages. Now we'll use the same logic and just shortlist the records in which the age is greater than 15. So this is a list that I have created, filtered data. In this list, I'm storing each record in the form of a dictionary that has age greater than 15. Let's run this code and these are all the 3 records. Now that you have this record, you just need to write them to a JSON file. In order to write them to a JSON file, we use the same method that we use for writing text files. We have given the write mode as W, we have given the file name. But what we do different here is, instead of using the write function, we say json.dump. Now we give the name of the variable in which our entire data set is present. We give the name of the file, it's read as F, we give the indentation space. When we execute this piece of code, you will notice that the filtered JSON is promptly made in your disk. Very straightforward, right? All of these records have age greater than 15. So this is how you work with JSON files in Python. Now you might have noticed that when we read JSON files inside Python, they look very similar to the default dictionaries that we have in Python. And nested JSONs look very similar to nested dictionaries in Python. And that is actually correct. When we are working with JSON data inside Python using the JSON module, we essentially get the data in the form of a dictionary and you can perform most of the functions on it which a dictionary has. Things like, suppose I want to access filtered data. So this is my list. So the first element is a dictionary. Now I can just say dot keys. So I'll get the keys. I can run the dot items function. I'll get the items. I can even do the dot values function. I'll get the values. So what happens under the hood is, this module of Python, which is JSON, essentially when reading a JSON file inside Python, converts it into a form of a dictionary so that it's easier for you to work with. So this is not something to worry about or get confused about. This is straightforward and it gives you more power because as a programmer, you already know how to work with dictionaries. So this was dealing with JSON data in Python. Now so far in the course, we have seen how to read different types of data files in Python. We also know that there are 5 major tasks of data science that can be done using Python. And in this module, we will specifically learn how to do this task, which is subsetting and modifying data. So here are some topics that we will learn about. First of all, we have subsetting. And under subsetting, we have 3 major types of subsetting the data. The first one is position-based subsetting. That is using row or column number to subset the data. We have label-based subsetting as next, wherein we subset data based on the labels that are given to the row. And we have value-based subsetting, wherein we subset data based on values that are present in rows or columns. To implement all of these techniques, we will learn to do a couple of things. First of all, how to access top or bottom rows of the data frame, then how to set rows or column filters, and much more. After that, we will learn about modifying the data, in which we will cover things like how to fill missing values in your data frame, manipulating values at either the row level or column level based on certain conditions, and so on. Now, under subsetting itself, there are two types of indexing schemes in pandas that are used to subset data. The first one is position based and the second one is label based. First, let's learn about the position based index. As the name suggests, it consists of basically an integer denoting the row or column position. The next is the label based index. Here, we will have labels like car FCD01 for our rows and columns. Let's now have a couple of examples to understand both of these techniques. First of all, when we say position based index, we essentially say, suppose I have this given data frame. Now each row has a position number attached to it. Like the first row has index 0, the second row has index 1, and so on. And this is essentially the same row number that you will find when you have this data set in an Excel file or a CSV file. When we talk about label based index, we are essentially talking about labels being given to each row of the data. Now this is a very high level difference. We will go into each of these techniques in more details in the upcoming videos so that you have a better understanding of them. But for now, here is another piece of information. Just like we had position based index for the rows, we also have position based index for the columns. So this column item identifier has an index 0 because it's the first column. Then item weight has the position based index 1 and item fat content has the position based index 2. So this was all about what we are going to study in this module. In this video, we will have an overview of different subsetting techniques that are used in pandas. And by utilizing code examples, we will cover all of these topics. What is an index? How to subset first n rows based on their position index? Can we change the index? And so on. So by the end of this video and the next videos, you'll have a very good understanding of how to work with subsetting in pandas. So let's start with the first step, that is simply importing the pandas library and reading the data using the read CSV function. So the dataset that we are going to use for this video is the same Big Mart sales dataset that we have seen earlier. Now we already know that there are two major indexing schemes in pandas. The first approach gives integer index to each row and column based on its position. So this is row number 1, 2, 3, 4, and because indexing starts in Python from 0, so this is row number 0, 1, 2, 3. Similarly, the column indexing starts from the leftmost column and starts with 0, 1, 2, so on. Now the second approach is this one, where we work with a label based index for both rows and columns. Now we have already talked a lot about index. Let's see what this index really is. So this is the data frame and let's see how is this index stored under the hood. Now if you have a close look, you will see that the index starts at 0 and it ends at 8523 with a step size of 1. What does this mean? First of all, let me show you the shape of the dataset. So the shape of the dataset is, it has 8523 rows and 12 columns. So a basic positional index in pandas actually starts from 0 and goes to the number of rows that are present in the dataset, which is this. And at each step, you give a step size of 1. So if you remember when we were talking about steps, when we were seeing the range function and the for loop and so on. So this is essentially saying the same thing, that my positional index will start at the number 0 and it will go to the total number of rows that are present in my dataset. Seems fine, right? Similarly, if you want to find what is the index for the columns in this data frame that we have just read, you can just do data.columns. And now that you have printed this value, you will notice that the columns have a label based index because each column has a name by default. So this is how a default pandas data frame has index. For row, by default it takes the positional index like this, and for columns, by default it takes the label based index because each column has its name. Now that you know about this, let's see a small example on how to utilize the positional index to get the first n rows of a data frame. this is where the head function comes into picture. Using it, you can access first n number of rows. So first of all, if you call this function without any parameter like this, you'll just get the first 5 rows. Now if you pass a parameter like 10, you'll actually get the first 10 rows. You can keep on changing this parameter to any value that you like, and based on that you will get the first 7 rows, first n rows basically. So n basically means whatever value you're passing here. Now this was a quick short intro to position based index and the concept of index in general. The next logical question that comes to my mind is, can we change the index of a data frame? The short answer is yes. So let's see how. So here what I have done is, I've created a list of 8523 random numbers. Let me show you. So this is the list that I have created. It has these random numbers, and the length of the list is actually the length of the data set that we have, that is number of rows. And we will be setting these random numbers as the new index of the data frame. So we do data.index is equal to this random list. Now let's see what happens once we have changed this. So now once again I'm going to use the head function to see the first 5 rows of the data frame. Let's see if something changes. Now do you notice something interesting? Let me show you. So here the first 5 rows have item identifier as FDA15, DRC01, FDN15, and initially we had FDA15, DRC01 and FDN15. So even though we manually change the index of the data frame, the order in which the rows are appearing is still the same. Now why is this happening? So basically this is happening because whenever we manually update the index of a data frame in Pandas, this new index is actually treated as a label for each of the rows of the data frame. So each of these numbers 575, 5923, 1171 are actually labels for each of these rows in the data frame. So this is a small example of label based indexing. And since our head function only works with position based indexing, it doesn't matter what label you give to each row. Whenever you call the head function, it will always show you the first 5 or first n rows of the data frame. This is something to keep in mind because this can cause great amount of confusion and might cause bugs in your code. Now this concept will be much clearer to you by the end of this module. So for now, let's move on. Now there is another way of changing the index of a data frame in Pandas, and that is using the setIndex function. Let's see how to do that. So before this, I'll just print the data frame as it is right now. So I'll just say data.head. So right now this is how our data frame looks like. We have these columns, outlet establishment year and so on, and the indexes are these random values. Now one of the advantages of setIndex function is you can actually pass in the name of a column of the data frame, and the setIndex function will create a new label based index using this column values itself. Let me show you what is actually happening. So I want to say for this particular data frame, this column outlet establishment year should be used as an index. Let's do that. And this is how you do that in code. So as predicted, the new index of this data frame is actually outlet establishment year column. And let me also show you what happens when we try to print data.index. It basically gives us the values of the column. So each row is now indexed by a year. So this is the second way by which you can change the index of a data frame. You can actually use this function to do a lot more, and that's why I'll recommend that you read more about this function in its documentation. Now before we proceed further, let me explain to you a couple of things. First of all, if you remember, we were passing 2 parameters here to this function, drop equal to true and in place equal to true. Let's understand what these 2 parameters mean. Now in order to explain these parameters, I'll have to read the dataset again so that I can show you the effect they have. So this is me reading the dataset again, and I'll first of all replace drop equal to true to drop equal to false. So basically I'm deactivating this parameter's effect. Let's see what happens. As expected, we have the outlet establishment year as the index, and we still have this as a column in the dataset too. So basically the drop parameter lets you drop the column using which you are creating the index. So if you do set the value of this parameter as true, what will happen is whatever column you're using to create the index, that column will be removed from the dataset. And this is a behavior that we usually want a lot, because then you are dealing with the problem of duplicate columns. But then again, this depends upon your use case. So this is a very important parameter to know. Now let's talk about the in place parameter. So just like the previous example, I'll first of all set the value of this parameter as false and show you what is happening. So I've said in place equal to false. So now we have the data frame whose index is set to outlet establishment year, and we scroll down and we say data.head. Now do you realize that something has gone wrong here? Even though when we execute this line of code, we get the correct data frame in which the index has been updated, after some time when we say data.head, we are still getting the old data frame. So this is what in place parameter is responsible for. In place literally means in place. So if you set this parameter as true, what you will get is the original data frame itself will be updated by whatever action you're performing. In this case, we are performing the action of changing the index, and whenever you call the data frame again and again in future, the index will be changed. If you say in place equal to false, what happens is Pandas creates a new data frame with the changes that you have requested and returns that data frame to you. So that's why when we were executing this, we were getting this output. So you can actually save this output into a new variable data updated, right? And instead of doing data.head, which essentially is the original data frame, you can do data updated.head, and this will give you the new data frame. So this functionality of whether you want to change the original data frame or whether you want to create a new data frame depends again upon your use case. So make sure to know when you need to use this. So this functionality of whether you want to update the original data frame or you want to create a new data frame actually depends upon your use case. But this parameter in place equal to true or false is actually a parameter that is very common in a lot of functions of Pandas. And that's why I thought it's a good idea that I explain it here itself. So now that we know how to change the index of a Pandas data frame using a column, the next question that comes to my mind is, do we always need to use numerical columns to set the index? Well, the obvious answer is no. You can also have categorical columns like item identifier, item fact content, etc. as indexes. Let's see how to do that. So in this case, I'll set the index of the dataset as item identifier. Now you already know why we have done drop equal to true and in place equal to true. Let's see how the data frame looks like. So now the index of the data frame is actually a categorical column. So each of these rows have a label which is the item identifier, and from the original data set we have removed this column. Let's check what is data.index. So this is very predictable. Now how can you subset data when you have label index that is categorical? This is where lock comes into picture. Lock is the property of a data frame using which you can actually subset the data using the categorical values or the labels that we had given earlier. So now I'm saying FDA15, this is the label, and for this label, get me all the rows of the data frame that have FDA15 as label. Now if I talk about it in business terms, this is essentially all the rows in the data set that are essentially sales record for this item FDA15. Suppose for example, this item was milk. So when we say FDA15 here, what we are subsetting is, we are subsetting all the sales record that this data set has for the item milk. This is what is happening. Now since we have already done a good amount of experimentation on the index of the data frame by changing it again and again, the next question that comes to my mind is, can you reset the index back to its original positional index? Well, you can actually do that in Pandas, and this is where the reset index function comes into picture. Using this function, you can make sure that whatever experimentation you have performed on the index for various reasons, at the end of it, the data frame reverts back to its original form, which is having a positional index. So once you have executed this line of code, reset index, when you do data.head, you will notice that the index is same. And if you want, you can again print the index. So the index has gone back to its initial state. Now this was all about label based indexing and how can you subset such kind of rows in Pandas. The next topic is, what if you want to subset your data based on the value of a column or a row? So let's have a small example. So this is our data. Let me show you data.head. this is how our data looks like. And we have this column, item type, and there are multiple types: dairy, soft drinks, meat, fruits and vegetables, household, etc. Suppose I want all the rows that have dairy as the item type. So this is how you can do that. This is the syntax to do that. You say data, you open the square brackets. Inside that you say data dot item type. So this column's value should be equal to dairy. And I want only such records wherein the item type column of data has the value dairy. So let's see what happens. Once you execute this line of code, you will notice all of the records that you're getting in output actually have dairy as the item type. Now those of you who are from an Excel background will find this nostalgic because this looks very similar to the filter feature in Excel, right? So these were 3 different ways of subsetting data in pandas: positional based, label based and value based. In the next couple of videos, we will explore each of these techniques in greater depth so that you have a very good foundation when you want to work with pandas. In this video, we will particularly focus on one kind of subsetting, that is position based. Now first of all, I'm going to import the pandas library, and we will need the same dataset of Big Mart sales that we have seen before. So this dataset has 8523 rows and 12 columns. So the first thing that comes into picture when you're talking about position based subsetting is how can you access top or bottom n rows of your dataset. So head function is something that we have seen earlier. So let me just revise it for you. So head function lets you see first n rows of your dataset. If you pass a number here, like I have passed 10 here, so you will get the first 10 rows. If you pass any number, for example 5, you'll get the first 5 rows. Similarly, we have another function in pandas, which is the tail function. So tail function lets you see bottom n rows of the data frame. Similar to head, in tail, if you do not pass anything, the default outcome is you'll get the bottom 5 rows. If you pass a number, then you'll actually get those number of rows. Like here I have passed 2 and I'm getting the bottom 2 rows. So the head and the tail functions, they work based on the position of rows, that is the positional index that we have here. And that's why whenever you give it any value here, it will always get you the top 10 or the bottom 10 rows of the dataset, irrespective of what is your index. And this is something that we have already learned in the previous videos. So I hope you remember that. So this was head and tail. The next question that comes to your mind is, how can you access rows in a particular range using the position index? So first of all, again, this is our data frame. And we know we have 8523 rows and 12 columns. So suppose you want to access the rows based on their position in a particular range. For example, I want to access rows from 10 to 14. So I'll just use this syntax and I'll get the rows 10, 11, 12, 13 and 14. Now this syntax is very familiar to the list slicing syntax that we have seen earlier. So I hope you remember that. You use a square bracket, you use a colon, you give a starting index and the ending index. And ending index is always excluded. So when you say 10 to 15, Python will return you from 10 to 14. Similar to list, you can give a step size here. So normally it skips one row, so 10 to 14. You can say 2 here. So this will skip 2 rows. So first it will say 10, then it will directly go to 14. Similarly, you can also use negative indexing here. Just like we used to use the negative indexing in list slicing. So suppose I say minus 10 and I leave this empty. So minus 10 means starting from the last row, go 10 steps back. So if I say minus 10, I'll get the last 10 rows. So let me say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the last 10 rows of our data frame. So similarly, you can pass other index here and you'll get those kind of values. And you can use all kinds of step values to make sure that you're able to slice through the data frame. Now when it comes to slicing through the data frame using positional index, we have another utility known as the iloc. So iloc essentially, as you already know, deals with position based indexing. So suppose my next question is, how can you select particular rows by position? So now I'm not worried about getting the rows in a range, but rather what I'm worried about is I want specific rows, row number 1, 5, 2, 4, 6 and 14. This is something that you can easily achieve using the iloc utility. So this is a syntax of using iloc. It is not a function, but it is essentially an attribute of the data frame itself. So you use two square brackets, and inside that you can pass the rows like this by separated by a comma. So if you run this piece of code, you will notice that all the rows that we have received from this query are actually the ones that we asked for. So 1, 5, 2, 4, 6 and 14, and in the same order. Now iloc is a very useful utility in pandas because apart from rows, you can also use it to get specific columns of your data using the positional index. So you know this column is position 0, this is 1, this is 2, this is 3, this is 4 and this is 5. So suppose you say I want rows 1, 4, 5 and 2 and I want columns 1, 3 and 5. Let's see what happens when I run this piece of code. So as expected, you have row 1, 4, 5 and 2 and you have columns 1, 3 and 5. So column number 1 is item weight, column number 3 is item visibility and column number 5 is item MRP. So this is the kind of advanced subsetting that you can do using the iloc utility. Now the good thing about iloc is you can use iloc to do the same kind of data frame slicing that we are doing using the square brackets here. So suppose you want a range of rows 10 to 15, you can just use iloc to do that. And the same negative indexing, same step size, all of the things that we were doing using just the square brackets, you can do using iloc. Apart from that, you can also access particular columns using their index and particular rows using their index. So iloc is kind of a utility built on top of this. So you can use iloc to do position based subsetting in pandas. In this video, we are going to particularly focus on subsetting based on label. So without waiting much, let's start. The first couple of things that we are doing are the same routine things. First of all, you import the pandas library. Second, you load the Big Mart sales data. And the third thing is use the .head function to get the first 5 rows of the data frame. So this is what we are doing. Now if you notice, right now our data frame by default is indexed based on its position. So we are going to change that and we are going to give a label based index to this data frame using the column item identifier. So this is the column item identifier, and using this column and using the set index function, we are going to change the index of this data frame. So let's do that. If you now use data.head, you will notice that the index has changed. So this is a new index. So given you have a totally new data frame, how can you select rows based on labels from such a data frame? This is the next question that we are going to solve. Well, this is where the .lock utility of Panda comes into picture. Using lock, you can fetch all the rows that have this label. For example, in this case, when I execute this line of code, I'm essentially able to get all the rows that have the label FDA15. In other words, these are the sales record in a data frame that belong to this item identifier. Isn't that logical? Suppose you want to find all the sales record that belong to this item identifier FDN15. You can just set the index as label index using this column and the set index function, and then you can just pass that item identifier inside the lock utility, and these are all the sales record in your data set that are for this given item identifier. So just like you can pass a single item identifier, similarly you can pass a list of item identifiers to the lock utility, and you can get all the sales record or all the rows in your data frame that have either this item identifier or this item identifier as the label. So first you have so many rows for FDA15, then you have all the rows for FDA03. Now apart from doing this, you can also specify what columns you need for these label indexed rows. For example, in this piece of code, I am saying I only need the value of the item fact content column for these two labels, FDA15 and FDA03. So for FDA15, these are the values for item fact content, and for FDA03, these are the values in the given dataset. This same feature can be extended to multiple columns by passing a list of columns inside the lock. So just like in the iloc initially, we are passing the row position index and the column position index that we need. In the lock utility, you can pass the row labels and the column labels that you need for your data. When you run this piece of code, you will see that you have nicely subsetted your data frame and you are able to view records that have specific row labels and specific column labels. Isn't that amazing? So this was subsetting the data based on label by using the .lock utility of Pandas. Now in the previous video, we also learned about the iLock utility. And in this video, we have seen that lock is a very useful utility when we are working with label based data. So a natural question that comes to my mind is, what's the difference between the two? Let's discuss this now. So first, we will create a sample data frame. Let me just run this piece of code. This data frame contains details about students with columns like gender, grade, marks, and their ID. Notice that the index is positional by default in this newly created data frame. Now, in order to understand the difference between lock and iLock, we're going to run a couple of experiments on this data frame. Let's do that. When I try to get the rows using this 2 to 4 indexing using the lock utility, I get an output like this. So I have 3 rows in the output. The first row has label 2, the next row has label 3, and the third row has label 4. If I use the same indexing in the iLock utility, I get a slightly different output. Now I'm getting 2 rows in the output, and the first row has label 2 and the second row has label 3. Now notice that I'm saying these things are labels and not index for now. Why is that? Well, we'll understand this better with another example. So coming to this example, first of all, we are sorting the entire data frame based on the marks column. So now this entire data frame is sorted in ascending order of the marks column. So 12, 14, 20, 21, 22. Notice that the index has jumbled up. So it's kind of labels right now. It's not positional index. Now let's run the lock on the new data frame first. So I'm saying 2 to 4. I'm using lock utility. Let's see what happens. This is what I'm getting. Now notice that lock just returns all the rows that fall between the rows having label index 2 and label index 4. That's what lock is essentially doing. Whatever things we have passed to lock, it has considered that these are label values and it's just finding the row that has label 2 and the row that has label 4 and all the rows in between it's just giving you. Now let's see what happens when we use the iLock utility with the same indexing. What is iLock doing? Well, let me see. It gives me a row that has the label index 4, which is this row, and it gives me another row that has the label index 1, which is this row. So let's see what is the position of these rows in this data frame. So 0, 1, 2. So this row has positional index 2, this row has positional index 3, and this row has positional index 4. So what has happened here is iLock has splitted your data frame based on positional index. It does not matter what value is shown here, but what matters is what is the original position value of the rows in the data frame. So when you say 2 to 4, it starts with the positional index 2. This is the row at that index, gives you that as the output, goes to the positional index 3. This is the row at that index, gives you that output, and ignores the last index, which is how iLock usually works. The way lock works is, it does not takes into account the positional index of the data frame. For it, all of these values are just label based index. So it just starts with the row that has the label based index 2. Then it finds the row that has the label based index 4 and just brings you all the rows in between. Now this is essentially the reason why the previous output of both the utilities was not the same. This is essentially what was happening here also. iLock was always considering the position based indexing and the lock was always considering the label based indexing. But we were not able to figure it out then because when our data frame was newly created, the position based index and the index that is shown here was matching. So this is the 0, 1st, 2nd, 3rd and 4th row. Once we sorted the data frame, we just changed these values while the position index stayed the same. So this is how lock and iLock essentially differs. iLock always looks at positional index and lock always looks at label based index. For it, these numbers 2 and 4 are nothing but numeric labels. Let me show you a small example to make it even more clear. So in this case, we were dealing with numerical label, and that's why we were facing slight confusion. Now, instead of using numeric based label, I'll set the index using a categorical column. In this case, what will happen if we use lock and ilock? Let's see. Now, if you use ilock 2 to 4, it will still work because we have established this that ilock only looks at positional index. So it will take the positional index at row number 2. So row number 2, 0, 1, 2. So this row has positional index 2. This has positional index 4. It ignores the last number that you have given in, and it gives 105, 102 row. This is what it says. Now try using lock. It just gives you a big error. The reason for that is lock is looking for these labels in your index. But in your index, you do not have numeric labels. You actually have categorical labels. So if you want to index things now using lock, you cannot give numbers. What you have to do is you have to give the categorical values that are labels. And if you run this, you will get the correct set of rows. So this is how label based indexing and subsetting is done in pandas, and this is how ilock and lock differs. Ilock only works with positional based indexing and lock works with label based indexing. In this video we will learn how can you subset the pandas data frame based on value. Now before we start, I hope you remember the lock utility that we have learned in the previous video when we were doing label based subsetting. That utility is actually very useful when we are doing value based subsetting also. So let's start. First of all, we are importing the pandas library. Then we are reading the Big Mart sales CSV file, and this is our dataset. These are the rows and these are the columns. Now, when we talk about value based subsetting, what we are trying to say is we want a set of rows and columns that satisfy a given value based condition. Now, what do you mean by value based condition? Well, this is an example of a value based condition. So the value is 1987, and the condition is we need all the rows from our data frame that have outlet establishment year as 1987. If you want to do this in code, you can use a basic syntax where you're writing the data frame's name, you open and close the square bracket, and inside the square bracket you write the condition. So for me the condition is the outlet establishment year should be equal to 1987. So data.outlet establishment year equal to 1987. Once you run this line of code, you will see that you have got all the rows from the entire dataset wherever the outlet establishment year is 1987. So we have 932 such rows, and if you remember, our entire data frame was 8500 something rows. Now just like you can write this condition using the square brackets to get a value based subsetting, you can write the same condition inside the lock utility too, and this will give you the same result, same 932 rows. Now this is something that I want you to keep in your mind, because by the time we reach the end of this video, you'll understand why we are discussing about lock also. So this was a single condition. What if you want to check multiple conditions and get the rows or columns that follow multiple conditions? So in this example, the two conditions that I want to check is my outlet establishment year should be 2009 and my outlet size should be medium. Let's run this. So I have 928 rows that satisfy this condition. Now do you notice this special symbol? Well, this special symbol is nothing but a symbol in Python that you use to denote the AND operator when we are working with pandas data frames. Now what this condition essentially says is you want both this condition and this condition to be true. So you want all the rows in which both the year is 2009 and the outlet size is medium, and this is what you will see in the output. Now just like AND, we also have the OR operator, and the symbol for OR operator is just this pipe sign. Now this condition basically says I want any row that either has a outlet establishment year as 2009 or the outlet size as medium. So let's just run this code and see what happens. So initially we had some 932 rows, now we have 2793 rows, and you can see that either one of the condition is true. So in this case the year is wrong but the outlet size is correct. In this case both are correct, and so on. So this is how you can use multiple conditions to do value-based subsetting in pandas. Notice that each condition is enclosed in its own circular parenthesis, and this is a good practice that you should always follow. If you're writing multiple conditions, always enclose each condition in its own parenthesis. And the symbols that we have is, for AND we have the ampersand symbol, for OR we have the pipe sign, and for NOT we just have the exclamation symbol. So if your condition here was, let me just remove this, you just want all the records or the rows from a data frame in which the outer establishment year is not 2009. So this is how you write the condition. So all of these rows you will see that the year is not 2009. Now the good thing about LOC is you can do the same thing even in LOC. Same multi-conditional subsetting for value. It will work the same. Now so far, even though we were checking multiple conditions, for each condition we were only checking one value. In this case it was 2009 for the outlet establishment year. For the outlet size it was medium. But what if you want to check a condition on a list of values, that is multiple values? Suppose now the question that I have in front of me is, I want all the rows that either has the outlet establishment year as 1987 or 1988 or 1999. So I basically want any row that has the outlet establishment year in one of these 3 years. And that's why we have used a OR here. So let's just run this line of code. And we get all the rows. We have like 1862 rows. And you can see that one of these 3 years is present in each row. Now, if you look at this code, you will notice that we are essentially repeating the same condition again and again in a code for a different value. Do you think there can be a better way to do this? Well, actually there is a better way to do this, and that is using the isIn function. So what isIn lets you do is, it lets you check for this same equality condition in a list of values. So now I'm getting the same result as above, but because I'm using the isIn condition, my code is pretty simple and straightforward. I'm just saying, give me any row from the data frame where outlet establishment year is inside this list. So it can be any value. You can add more numbers to this list like 2001. You can delete numbers from this list. What this lets you do is, it essentially lets you achieve the same thing by just writing less amount of code. And in real world example, trust me, a lot of times you have certain values as a list and you want to see all the rows that fall into at least one of the values given in the list. So this was the isIn function. Moving forward, up until now, we have seen how to subset rows based on value. The next logical question is, do we have a similar way of subsetting for columns? Well, that's what we are going to learn next in this video. But before that, here is a bit of reminder that you should know. Suppose you have a list of columns that you need specifically in your outcome. You can just pass that list of columns inside the square brackets with your data frame, and you'll just get those specific columns when you're subsetting. The same concept of passing a list of columns can be extended when you're working with value-based subsetting. So suppose this is your condition, you have multiple conditions for your rows. Now, if you just pass the list of columns, the output will only have all the rows that first of all satisfy these two conditions, and in the output, you'll only get a limited set of columns that you have passed to the data frame. Suppose you just remove this part of the code, you will see that you're getting all the columns. But in reality, a lot of times we are only looking for specific columns and specific rows. And this is how you can do that in pandas. Now this is an example of our advanced subsetting, wherein we are not only subsetting based on the row, but we are also subsetting for specific columns. So this is something that I encourage you to go ahead and try a lot. Coming forward to lock, you can do the same thing in lock, but now the syntax is even simpler. So here you created another square bracket, inside that you are passing the list of columns. In lock, you can just pass the condition that you want to check, give a comma and just pass the list of columns, and you will get the same output as above. same 932 rows and 4 columns, and same 932 rows and 4 columns. So the point that I'm trying to drive home is whatever value based subsetting that you can do using the normal square brackets syntax, you can achieve that using log but with a simpler and more intuitive syntax. Now we'll discuss more about this point at the end of this video. For now, here is another kind of subsetting that I want to show you. In this subsetting, we want to select columns with specific data type. So we already know each data frame has the D types property, using which you can just see what is the data type of each column. So item identifier is an object, item weight is a float, so on. So objects are usually categorical columns that hold categorical values in a data frame. Float 64 holds the real values, and int 64 are basically integer columns, like year is integer, but item MRP can be a decimal or a real value, that's why it's float 64. Now suppose you only want to see what are the categorical columns in your data frame. You can just use the select dtypes function. So you have the data frame, use the select dtypes function and just pass the object, and you will get only those columns from your data set which are categorical in nature. Similarly, you can do the same thing for say float 64, and you'll get only those columns in your data set that are numerical, more specifically that have real value. If you do this as int, you'll get only the year column which has integer values. So this was essentially subsetting based on value. We saw two syntax, the basic square syntax using the square brackets and the log syntax. The next question is, when both of these approaches work almost the same, then when to use which? So let me tell you a couple of points to make it easier. First of all, the log utility provides a simpler syntax over the normal square utility. Second, in terms of performance, when you're considering the execution time, there is no difference. Both of them work the same. Now the good thing about log utility is it also works with label based subsetting. So basically using one utility, you can do both label based subsetting and value based subsetting, which is kind of useful. And the last point is the square bracket based utility sometimes has unwanted behavior. So as a good practice, generally people recommend to use the log utility. I've provided the link here. You can read more about this behavior on this link. And this is essentially what is value based subsetting in pandas. In this video, we will see certain challenges that you face when you're working in data science in a real world scenario, and how can you solve those challenges using pandas. First of all, like always, let's load the pandas library, read the dataset, and this is how our dataset looks like. It's the same Big Mart sales dataset. The next thing is our first challenge. So our first challenge is how to impute the missing values in any column. So when you're working with real world data, having missing values in one or two columns is a very normal thing. Let's see if our Big Mart sales data has missing values. In order to check whether we have missing values or not, we are using the isNA function that basically gives you true or false boolean based values to tell whether a value is missing or not, and .sum function that will basically total the number of missing values. So we have 1463 missing values in the item weight column, and for the outlet size column we have 2410 missing values. Now before we can start with imputing the missing values in these two columns, let's first get the rows in which item weight is missing. So in order to do that, we'll use the log utility that we have seen before. Inside log, we'll write this condition. So remember I told you that isNA function essentially gives you true or false for each value to tell you whether that value is missing or not. So that's what we are going to use here. The condition is for the item weight column, if the output of isNA function is true, then return the row, because the isNA function will only be true when the value is missing. So when we run this logic, you see we get so many rows, around 1463 rows. That is what we got here. And in each row, the item weight is NaN. That's a missing value. Now the next thing that we can do to fix this missing value is we can replace all the missing values or fill all the missing values by the mean of this column. So essentially, for whichever item we do not have the weight, we'll just fill in the mean weight of all the items there. Now why we are taking mean is something that you will learn in the EDA module if you have taken the applied ML course. But just as a rule of thumb, a basic way of fixing missing values is, and when you are dealing with numerical column, you impute by the average of the column. So now I want to fill the item weight column of this data frame with the mean of the item weight. So the way we do that in lock is, first of all, we use the same condition on the row, the same condition that gave us all the rows in which item weight is missing. Then in the column section of the lock condition, we fix the item weight as the column. So let me just show you what this gives. When we run this piece of code, we only get the item weight columns values for only those rows where it's missing. So now, because we want to replace all of these missing values with the mean of the item weight column, we can just do this. So this is the data frames item weight column and the mean value of that. Let me just show you what this value is before we put it. So this value is 12.85. Now when I run this piece of code, all of these rows in which the item weight columns had missing values will be replaced by 12.857. So let's do that. Now if we use the same logic of checking missing values, you will see that the item weight column has no missing values. So this was item weight. Let's try to fix outlet size. Now if you remember from our initial head of the data, you will know that outlet size is actually a categorical column because the data type is object, and if you just print the value of outlet size, let me show you data.head, you will see that the outlet size is actually a categorical column where you have high, medium and small such values. So as I told you some time ago, that when you're trying to fix missing values in a categorical column, you replace the missing values by the category that has the most frequency, and the most frequency is something that we get using the mode of the data. So what I'm doing is I'm saying the outlet size column, find the mode of that column. So medium is the mode of that column. Medium is the value or the category that has come the most in the outlet size column. Let me just check it once more. I'll just say data.outlet size. I'll use this very useful function known as value counts that essentially gives you the count of each category in a column. So let me just run this code. So if you see this count of categories, you will see that medium has the highest number of counts in this outlet size column. So we are right, this is medium is actually the mode of this column. Now previously we were imputing missing values by using a complex logic using the lock utility. Same thing we can do here. We have got the mode. So what I'll do is just below this I'll create a cell. I'll write this logic. Now instead of item weight, we want to make this outlet size. Outlet size is n equal to true. Then we want to fix the outlet size column because this is the value we want to update, and here we can just give the value medium. So we can do this code the same lock method, but apart from that there is a simpler way to impute missing values in pandas, and this is the way which I recommend you to use again and again, and this is using the fill_na function. So the fill_na function, as the name suggests, basically takes a column of your data frame, and you can pass the value here, whatever value you want to replace the missing values with. In place equal to true basically make sure that this happens in the original data frame, and the minute you run this piece of code, you will see that all the missing values of the outlet size column has been fixed. So fill_na is some function which is very important when you want to work with missing values in pandas. Using fill_na, you can even solve this challenge of imputing the values of item weight column. In fact, this is something that I recommend you to go ahead and try on your own. And just in case, if you face any doubts, you can always go to the official documentation of the fill_na function. You'll get what each parameter means, how to call the function, and a couple of examples on how you can use this function. Now moving on, this is how our data set looks like. The next challenge is we want to update the values of a column. Before we do that, let's just see what are the value counts for item fat content column. Now you already know what value counts as a function does, it basically tells you the frequency of each category in a categorical column. We have used this previously here to get the category wise frequency for each category medium, small and high in the outlet size column. So we will learn the same value counts function on the item fat content. Now if you see the categories that are present in column, you will realize that a lot of categories are repeated. For example, low fat and LF and low fat in capital letters are the same category, while regular and REG are the same categories. So this is another challenge that happens a lot when you're working with real world data, which is basically sometimes while collecting the data or while processing the data, people do not follow the guidelines. So what happens is you have the same information but written in different ways. In order to fix this, we will use a function known as map function. Now map function is something that we have seen in detail in Python basics. In case you do not remember how map function works, I'll write the name of the video in which we have taught this and you can go back and refer that video first. But for now, let's create a mapping. So we know that low fat, LF and small low fat, all of them are single category. So I'll create a mapping in such a way that capital low fat is also LF, LF is LF and small low fat is also LF. Similarly for regular, full word regular is capital R and small reg is also capital R. So this mapping is the actual mapping of the underlying data, even though we have 5 different categories, but essentially these are 2 categories written in different ways. Now this is where things become interesting. Using the map function that we have learned initially in Python basics and this mapping that we just created, we can update this entire column's value so that we only have 2 categories, LF and R. Let's see how to do that. So this is the item fat content column and we are saying equal to this value. So let me just show you what happens when you run this piece of code. So basically, item fat content column of the data, map it using this mapping. This is what this piece of code says. When you run this piece of code, you will notice that the output has only 2 categories, LF and R. So basically, when you save the value of this piece of code inside the data.itemFatContent column, you will realize that the column has been fixed. Now, if you do the value counts on the same column, you will notice that you are getting the same proper categories for LF and R. So this was challenge number 2. The next challenge is how can you create a new column by modifying an existing column. Suppose you have a column item MRP in a current data set and item MRP is actually the price of the item in Indian currency INR. Let me just show you. So this is the item MRP and suppose you want to create a new column item MRP in USD, which is basically the price of the item in US dollars. In order to convert this price in Indian rupees to the US dollars, you have to divide them by 74. Now this is something that you can do using the apply function in Python. So before we come to the main solution of this challenge, let me tell you a bit about apply function. So I say data.itemMRP and I'll say apply lambda x. So the apply function essentially lets you iterate over all the values of a column. Suppose I say do x into 10, then all the values of the column will be multiplied by 10. Suppose we say x plus 100, then you will see that all the values have been added by 100. And suppose we divide x by 100, you will see that all the values are divided by 100. So using the apply function on a column and using the lambda function inside, we can essentially do any number of manipulations on a column itself. And the good thing about apply is it returns you an entire series which you can equate to a new column of your data frame, and this is how you can create a new column in its entirety. So let me just write code. If you want to convert the item MRP to US dollars, you will divide by 74, right? So these are the values in dollars. Now because this function returns you an entire series of values, you can just equate this series of values as a new column to your data frame. So till now, if you just check your data frame, you will notice that you do not have any column known as item MRP in US dollars. So there is no column like that. Once you run this piece of code, now if you do again data.head you will see that we have this new column item MRP in USD. Let's just see both of these columns together. So this is how you can add a new column to your data frame and update the values of a previous column, make some changes to it, divide, multiply, add it, and whatever operations you perform on this value inside the apply function, you can just equate it as a new column of the data frame itself. Now the good thing about the apply function is you can also call normal functions inside this lambda function. So let me just show you another example. Suppose there was this normal function convert price, and you want to say price is equal to price divided by 74, and suppose after dividing by 74 you want to add a constant to price, just assuming price equal to price plus 1.28 return price. So this is the function we have defined convert. Instead of calling just the lambda function inside the apply, you can actually call the price function inside the apply. This way, suppose we say a new column updated. So suppose you give convert in the apply function and we create a new column updated. When you run this piece of code, you will notice that you have another column in your data, that is the updated column, and all the changes that you performed on this, that is divided by 74 and add 1.28, have been updated in this column. So this is the advantage of using apply function on columns of your data. You can either write a simple logic using the lambda construct here itself, or you can call a full-blown function and do complex stuff inside the function, and apply will make sure that this function has been applied to every value of this column. Coming to another challenge. So as you already know that our dataset has a lot of categorical columns, but when you are working with machine learning problems and when we are doing modeling, for machine learning algorithms, we cannot give categorical input as text itself. We need to convert these categorical inputs to some numbers like 0 or 1 or 2. And this is something known as one-hot encoding in the field of data science. So suppose you have gender column and you create two new columns, is male and is female, and you just give 0 or 1 for each row of the data set, whether in that row there is a male or a female present. So in this row, female is present, so you say female as 1, male as 0. In this row, female as 1, male as 0. But in this row, you say male is present, so male as 1 and female as 0. And that's how you encode your entire data set, so that for one categorical column, you have two columns, one for each category. This is something that you can easily achieve in Pandas using the getDummies function. So let's see how to do that. First of all, have a look at our dataset again. We currently have 14 columns in our data, and a lot of columns like item identifier, item fact content, item type, etc. have categorical values. So if you want to create one-hot encoding for each categorical column in your dataset, you can just use the pd.getDummies function. Let me show you what this function does. And now if I access the head of the data, you will see that for each of the category, for each categorical column, we have a new column. For example, outlet size small is 1, outlet size medium is 1 column, outlet size high is 1 column. Initially, outlet size was a single column and there were these three categories, high, medium and small. But now we have three different columns and we have 1 or 0 marked in those columns based on this encoding scheme that we just discussed. So now let's just see how many new columns we have. We have 1600 columns. So even the one-hot encoding is a good way to convert your categorical columns to numerical columns. It leads to a lot of dimensionality in your data, which basically means you have so many columns and just becomes sometimes difficult to work with these many columns. So this is a trade-off that we see a lot in machine learning, and if you're part of the Applied ML course and if you're going to the next couple of modules, you'll understand how to deal with this challenge. But for now, using getDummies is a good way of converting all your categorical columns to numerical columns like this, using the one-hot encoding scheme. In this module, we are going to learn the next task that is important when you're doing data science with Python, that is preprocessing and aggregating data. So let me show you with a couple of examples what do we mean by that. First of all, you know that when you get raw data, we perform a couple of pre-processings on the raw data to make it more structured so that we can build better models with that and we can extract better insights from the data. One such preprocessing is working with time series data, and this is what we'll cover in this module. Apart from preprocessing, we also closely work with sorting data in real life. For example, you have this data frame in front of you. Suppose you want to sort this entire data frame based on grades of each student, so that it's easier for you to see which students topped in the class and which students could not do well. This is known as sorting on the grade column. Apart from that, you might also want to sort this data frame based on roll number, so that you know what is the sequential order for each student to come and give in the exam. So such sorting you can actually do very easily in Pandas, and this is what we will see in this module. Apart from preprocessing and sorting, sometimes when you look at your data set, you have questions like this. For example, what is the mean sales for different outlet sizes and location type? So you want to understand how sales gets affected by a combination of the outlet size and the location type of the outlet. By using the power of aggregation, you can get results like you see on your right. In this example, for each outlet location type and each outlet size, we have found the mean sales. So what kind of information does this give us? Well, for starters, you can see that if the tier of the city is 3, then high size outlet perform better in sales than medium size outlets. But if the tier of the city is 1, you can see that outlet size that has medium size perform better than outlet size that has small size. So things like this and a lot more questions that you get when you look at your data can be answered by using the power of aggregation. So that's why in this module we will learn some techniques on how you can preprocess your data in Python, how you can sort your data frames, and different ways of aggregating data in Python. So first of all, we'll just import the Pandas library and we'll create a sample data frame for this video. So this data frame has essentially details of students, things like their roll number, grade, name, marks, and city. So when you look at this data frame, what is the first thing that you would like to do? The first thing that I would like to do is I want to sort all the student details based on their grades, so that people who have got better grades like Pratik and Karthik, they should be at the top, and people who have got not so good grades like Piyush should be at the bottom. Now this is something that you can achieve using the sort values function of the Pandas. The sort value functions takes a data frame and it takes a lot of parameters, but one of the most important parameter is the by parameter. In this parameter, you basically give the name of the column on which this entire data frame should be sorted. So in this example, I have given the name of the column as grade because I want this entire data frame to be sorted by the grades. Let me just execute this cell. So this is the final sorted column. As you notice, people who have got better grades like A are at the top, and people who have got not so good grades like C are at the bottom. Similarly, you can sort this entire data frame based on roll number values also. You will notice that the entire data frame is sorted and the roll numbers are in a sequential order. Now have a look at this example. When we just sorted by grade, even though the sorting based on grade was perfect, but people like Karthik are coming after people like Pratik, even though Karthik has higher marks than Pratik. In order to fix this, we can actually sort on two columns. First, we'll sort in the ascending order on the grade column so that A scored people come first, and then as the grade becomes worse like C, D, and E, they should come at the last. Second, we want to sort this data frame on the marks column, but marks should be in descending order so that people who have scored higher marks should be at the top. Let's see how to do that. So I'm using the same sort value functions. The by parameter now has a list of columns. First, it will sort based on the grade column, and next it will sort based on the marks column. Then we also pass another parameter which is ascending. So ascending basically says whether you want to sort the data frame in ascending order or descending order. So if you give true, then it will become ascending. If you give false, it will become descending. So for ascending also we have passed a list of parameters. The first is true because for grade we want the ascending order. The second is false because for marks we want the descending order. Let's see what happens when we run this. So this essentially solves a problem. First of all, we have sorted the entire data set based on grades A to C, and then based on marks. in a descending order. So Karthik has A grade and 22 marks is highest. Then Pratik, who has A grade but 20 marks, which is slightly lower than Karthik, is the next highest. So this is what we have done using the sort values function. Let's see how our data frame looks like. Well, isn't this surprising? Even though we have sorted it clearly, the data frame is still not updated. Now this is where the concept of in place equal to true comes in. Remember that this is something that we have seen again and again in the course. In place equal to true. Once we do this, the original data frame itself gets sorted, and this is the result that we have. Now one thing you might have noticed in this data frame is that the index column is jumbled because of all the sorting. So suppose we want to update this index column so that it displays the proper positional index of the new data frame. Well, you can do that using the reset index function of the pandas. So you say data frame.reset index. Now you have the index column that is sorted and fixed for the new positional index, but you have a new column index that holds the old index. Now this is something that we no longer need. So while calling the reset index function, just say in place equal to true and drop equal to true. And now you have a brand new data frame in which everything is sorted in the way that you want it to be, and even the index is the right positional index. So this was about sorting in pandas. Now in real life, you do not get data from the single source. You usually have multiple sources or multiple files which you need to combine to make your entire data set. And that will be the topic of this video. In this video, we will see how can you concatenate multiple data frames in pandas. So first of all, just import the pandas library. Now for this video, we have 3 different CSVs: outlet size small, outlet size medium, and outlet size high. These are the CSVs. Outlet size high. So this has all the records that are for the outlet size high. Then there is another CSV that has all the records for the outlet size where the outlet size is medium. And then there is the third CSV where the outlet size is small. So in real world, you usually get data split into different files, or when you're collecting data from different sources, you have multiple files like this. So let's see how can you work with such files. First of all, I'm going to load all of these 3 CSVs in pandas using the read CSV function. Now let's just check the shape. So the outlet size small has 2338 rows, the medium one has 2793 rows, and the large one has 932 rows. Now let's look at the data for all the 3. This is outlet size small, this is outlet size medium, and this is outlet size large. Now all of these data frames have all the columns that are same. The only difference is this data frame only has records where the outlet size was small, this was for medium, and this was for large. So if you want to combine them and create a complete single data set, what you can just do is you can take this CSV for example and just stack below this CSV these rows, and then below these rows you stack these rows. So you can just add or append the rows of each of the CSV one below the other, and because all the columns are same, you won't have any issue and you will have your entire data set in which you have all the records irrespective of the outlet size. So this is something which is known as concatenating data frames in Python, and you can do that using the concat function. So let's see how to do that. First of all, we create a list of all the data frames. Then we say pd.concat function. In that we pass the list and we say axis equal to 0. Axis is equal to 0 means we want to stack each of the data frames one below the other, that is row wise. So when we execute this, this is the new shape of the data that we get, which has 6113 rows and 9 columns. Let's see what is the final data frame. So the final data frame looks very similar to the original ones. All the columns are same. The only difference is we now have more rows because we have combined all the 3 data frames. So this was concatenating or appending rows one below the other. The other way that you can combine data frames or concatenate them in Python is, instead of doing them like this, one below the other, row wise, you can also do them column wise. So you can add a column on the right side of the data frame. Let's see how to do that. First of all, I'll create a sample data frame like this. Now this data frame has information about students like grade, marks, city and roll number. Suppose you want to add another column that has phone number of the students. In that case, suppose you have this data frame of phone number. So this is just one column and you want to append this column on the right side of this data frame. Now in this case, you can use the same pd.concat function. Similarly, you can create a list of both the data frames. On the left, we give the original data frame, and on the right, we give the phone number data frame, because this is how we want to append it. And this time, we give axis equal to 1. So axis equal to 0 meant that we want to do the concatenation row wise, one below the other. Axis equal to 1 means we want to do the concatenation column wise. So once you run this line of code, you will notice that this column or this data frame has successfully concatenated with this original data frame. So this is how concatenation works in Pandas. In this video and in the next video, we will understand how can you implement SQL-like joins in Pandas. So let's start. Just to take an example, suppose you have this data frame where you have data of students which contains columns like their roll number, name, grade, marks and city. Suppose you get a new data frame in which you have the city names and the state names for each city names. Now using these two data frames, you want to update the original data frame in such a way that we have all the right state names for each row. This is something you can achieve using the left join of SQL. So the way left join works is, you take this entire data frame on the left and then you take the right data frame. On the column that is common, which is the city here, you combine both the data frames. And from the right data frame, you only include those rows that have a corresponding city in the left data frame, which is basically saying that only for Gurugram, Delhi and Hyderabad, pick up the state names and combine. Suppose there was another city here like Bangalore, then in that case, a left join would have ignored Bangalore in the final data frame. So this is a very basic description of how a left join works in SQL, and this is something that you can do in Pandas. Next, let's take an example to understand right join. Suppose with your initial data frame of students, you get a new data frame. Now these are a bunch of roll numbers. Suppose these are the students that have scored really well in the exam. So given these roll numbers, you want to find out all the other details of those students. For example, their name, grades, marks, so on. This is something that you can achieve using a right join. So just like left join, in the right join, the focus is only on the right data frame. So when you combine these two data frames using the roll number as a column, you only include those rows for which there is a corresponding roll number in the right data frame. In this case, there are only two rows. One is for Arvind and other is for Piyush. This is essentially the concept of a SQL right join. Now suppose you want to understand how a full join works. For this, let's take this example. Now these students have participated in a placement drive and some of the students have actually got placed. So these are the roll number of 3 students, their company name and the package that they have gained. Now your task is, you want to update this original data frame with this additional information where you want to also include the company and the package for all the students that are placed. This is something that you can do using a full join. We'll again join both of these data frames on the roll number column, and only those students for whose placement details we already have in this data frame will have a corresponding company name and a package. For every other student, for example Pratik and Piyush, because we do not have their placement information, we'll just have empty values in front of their names for the company and the package column. So this is a basic concept of a full join in SQL, and this is also something that you can do in Pandas. And finally, in order to understand another type of join, that is inner join, let's consider this example. In this case, consider that these students actually participated in a placement pool drive. In a pool placement, what happens is a lot of students from different colleges come together for a same company or for a couple of companies. So now you have two data frames. This data frame is of ZU University and this university has these students, and this is the final outcome of the entire placement drive. So from ZU University some students got selected, from AB University some students got selected, and so on. And now ZU University comes to you and says, okay, give me details of people who are selected from my university. In order to find information using these two data frames, this is where you will use an inner join. What an inner join essentially does is, it takes these two columns, college and name, from both the data frames and only includes rows that have common values in both of these columns. So in both of these data frames, for the college and the name column, only 3 rows have same value or common values. ZU University Arvind, which is here, ZU University Rahul, which is here, and ZU University Piyush, which is here. So in a way, you can think that inner join is intersection of both of these columns. When you perform this inner join, you will get this results. Now this is a basic description of SQL inner join. So all of these joins are very useful when you're performing real world data analysis and you're testing your hypothesis and so on. And that's why in the next video we will understand how can you implement these joins in Python using pandas. In this video we will implement the SQL-like joins that we have just seen in the previous video using pandas. So first of all, let me create the default data frame. So this is the initial data frame that we have, student df. Then let me create another data frame that is a state mapping. So there are these cities and there are these states, and what we want to do is we want to update this data frame by the name of the state using this mapping that we have. So as we know from the previous video, in order to do this, we have to use a left join, and the join that we want to perform is on the city column, right? So you can use the merge function in pandas in order to perform SQL-like joins. So this is the initial data frame, the original data frame, and this is the mapping or the other data frame that you want to merge it with. The how parameter basically tells you what kind of join you want to perform, left, right, inner or outer, and the on basically tells you on which column you want to perform the join. So let's see. So we have combined both of these data frames, and easily we have been able to get the state name for each city. So notice something interesting here. Let me just give you the example. So this was the city state mapping. We also had a city known as Faridabad whose state was Haryana. But because we were performing a left join, we only included those state names for which a city was already present in the left data frame. So that's why we ignored this city. Otherwise, we have the state names for all the other cities. So this is how a left join works, which is basically, I think if you look at the diagram, it will be much more obvious to you. You take the entire data set from the left table and only the relevant values from the right table. You can say these are relevant values, you can say these are corresponding values, or you can say these are matching values. But the basic idea is same. Even if there are other columns and other information in the right table, you ignore them and you only include those information from the right table that match with the corresponding information from the left table. In this case, only the state name of those cities that are present in the left table. And this is left join. Now we have the roll number data frame. So these are the students for which we want to find more information. These can be the toppers of the class. Now you have the original student data frame that we have seen earlier. Let me just print it again for you. So this is the original data frame, and we are interested in finding more about these two roll numbers. So these two roll numbers are Arvind and Piyush. So in order to find that, we'll perform a right join. And the reason for that is, this is the second data frame, roll number, and this is the first data frame, student df. In this example, all the focus is on the second data frame. We do not care about any other roll number. We only want information that match with these two roll numbers. And that's why we do a right outer join on the column roll number. So we only get information about these two roll numbers. Even though the left data frame has a lot of information about other students, it just doesn't come here. So this is a right join in pandas. Now we were talking about students getting placed into companies, and these were the 3 students who are placed in these 3 companies with these 3 packages. And we also have our original data frame where we have basic information about each student. Let me just print the original data frame again. So this is the basic information about all of these students, and you want to just update this data frame with their placement information for each student for whom it is available. Now this kind of join is known as a full join, and the reason for full join is it combines all the rows and columns from both the left and the right table and tries to match things correspondingly. For those elements where the corresponding element is not present in another table, it just gives you empty values. So let's see what is happening here. For how I select outer because I want to perform outer join, and this is what happens. Notice that in the left table we had all the students' name, and in the right table we only had 3 students' information. Apart from those 3 students, for the next 2 students of the left table we do not have any corresponding value in the right table, and that's why there are empty values for the company and the package, because for these 2 students, Pratik and Piyush, we do not have the placement information. And this is how an outer join works in Pandas. Coming to the inner join, let me just create the data frames that we saw. So this is the first data frame. This is the ZU University. These are student name, grade, marks and city. And this is the result of the pool campus placement. Now, ZU University is particularly interested in understanding how many students from its university got placed and for which company and for which package. This is something that you can do using the inner join. As I told you in the previous video also, inner join is like an intersection and an outer join is like a union. So just like a union combines all the rows and columns from all the tables, an intersection only looks for those rows and columns that are common. So using the college and the name column of these 2 tables, I only want those rows in which the entries are common. So let's run this. How is inner? That means the inner join, and on is 2 columns that we have passed as a list of columns. Once you run this, you will actually see you're only getting 3 results because only these 3 results have college and name matching in both the data frames. For other students, they are from different university, that is AB University, so they do not fill the criteria, and that's why we do not have them in the results. So this was a quick revision of SQL-like join in Pandas and how to implement them in code. Now let's try to solve a problem statement. So you remember initially in the concatenating video, we created a data frame by concatenating different rows and columns. So this is that data set. Now there are a couple of columns already present in the data set, but now we have another CSV file, outlets data. This CSV file has added information, that is outlet establishment year, outlet size and outlet location type, that is not present in this original CSV. Now we want to combine this information with this data frame so that this data frame has more information. I want you to pause the video for a moment and just think about 2 things. First of all, what kind of join we need to perform here, and second, what column on which we can perform this join. Go ahead and think and pause the video. I'll wait for you. So let's begin. First of all, something that should be very obvious to you is outlet identifier is the only common column in both the data frames. So whatever merge or join we are going to perform, we are going to perform it on the outlet identifier column. Second thing that should come to your mind is, suppose this is your data frame 1 and this is your data frame 2. So we want to include all the rows and columns of the data frame 1 and only matching rows and columns of data frame 2. This is an example of a left join. So let's see. We are performing a left join on the outlet identifier column. Let's see what happens. When you combine both the data sets, you'll see that now we have 12 columns and the same 6113 rows. Isn't that amazing? Now this is actually where SQL-like joins in Pandas become very useful in real-world data science. Apart from that, let's take another example. So we have this combined data with us, this data frame. Now we have new data frame, that is item data. So this data frame essentially has a couple of item identifiers. To be specific, it has 100 item identifiers. Now what we want is, we want to fetch more information for all of these 100 item identifiers by taking advantage of this data frame. Now once again, pause your video and think about 2 things. First, what kind of join we are going to perform, and second, on which column we can perform this join. I think you would have already figured it out by now, but let me just tell you. First of all, the only common column is item identifier, and on that column we are going to perform this join. Second, in this case, we are only interested in finding the information about this data frame, about the IDs that are present in this data frame. For that, if we consider this is the left data frame and this is the right data frame, then we can perform a right join. Let's see. So we are performing a right join on the column item identifier. So now you have all the information for these 100 item identifiers in our outcome dataset. So this was implementing SQL-like joins in Pandas. I hope you had fun. In this video, we will learn how can you perform aggregation and summarization on your data frames in Pandas. So let's start. First of all, we'll just load the Pandas library and we will load a Big Mart sales dataset. So this is how our dataset looks like. Now the basic aggregation that you can perform on any dataset is you can calculate things like sum, mean, median and mode of a column. So we have a numerical column item MRP. Let's try to aggregate this item MRP. So the total sum of the column is this much. Then if you want to find the mean price for items, that is 140.99. Similarly, the median price is actually 143. And the mode is something that we calculate for categorical columns. The reason for that is mode is the category that has the highest frequency. So for our outlet type column, that is a categorical column, as you can see, the mode is supermarket type 1. So this category has the highest frequency in this column. Let's just confirm that. So at this point in the course, you're already familiar with the value counts function. So when we run the value counts function on the outlet type column, you will see that the supermarket type 1 has the highest frequency. It's occurring 5577 times. And that's why this is the mode of a column. Now apart from these, Pandas also provides you a describe function. The describe function essentially calculates a summary that consists of similar things, but only for numerical columns. So let's see. So these are the numerical columns in our data set, and the describe function gives you basic summary like count, mean, standard deviation, minimum value, the quartile range, and the quartile values like 25%, 58%, 75%, and the maximum value. For example, for item MRP column, the minimum value for the price is 31.29 and the maximum value is 266.88. Apart from this, you can also find how many missing values are there in all the columns. So this is something that we have seen previously, which is you say the data frame name, you apply the isNF function, and then you apply the sum function on that. So this basically tells you how many missing values are there in whatever columns in your data frame. So as you can see, we have missing values around 1400 in the item weight column and around 2400 in the outlet size column. Now the next thing that comes to your mind is, what if you want to group the data based on categories of one column? Now this is something, if you are coming from either a Excel or SQL background, you will know that group by is an operation that you use a lot in your day-to-day data analysis tasks. And this is something that's available in Pandas too. So suppose, let me just show you our initial data frame. So this is our initial data frame, right? And suppose we want to group by all of these rows based on item type, whether it's a dairy, soft drink, meat, fruits and vegetables, or so on. So we'll use the group by function and pass in the column name item type. So this is D. It says it's a group by generic object. Let's just have a basic understanding of how D looks like. D dot first. So this is how the first entry of D looks like. So there are these buckets which are essentially the item types: baking goods, breads, breakfast, so on. And each bucket, all the rows have been sorted. So if you just run a loop over D, you will be able to find this entire bucket list, and in each list we'll find how many rows are there. But we are not going to do that because It will take some time, it will just give a long output. But let's go to the next step. Let's use this group by that we have just created. So now what I want to do is I want to find the mean of all the numerical columns based on these categories. Let's see what's that. When you just say d.mean, for all these item types, we have taken mean of all the rows that were present in each item type. So suppose you are saying that the item MRP mean is 126.38 for baking goods. This means all the rows of all the different items that come under the baking goods category, the mean of all of those rows is this. The mean price of all the products that come under baking goods is 126.38. Similarly, for breakfast food, for canned, for dairy, for frozen food, you get the idea. Now suppose you just want one column, so you can just give the column as a extended parameter using the square brackets. So these are the mean item price for each item category. For baking goods, this is the mean. For breads, this is the mean. For breakfast item, this is the mean. So group by is something we use a lot in real world data analysis, and a lot of people who come from SQL background and Excel background find this very familiar. Similarly, just like we did mean, you can just do max. So for baking goods, the maximum item MRP is 265. For breads, it's 263. And for starchy foods, it's 263. You get the idea. So this was grouping your entire data frame on a single column, that was item type. Now what if you want to group this entire data frame on multiple columns? Well, that is also something that you can do using group by. So what we'll do is, we are grouping this entire data frame first on the outlet size, which is small, medium, high. Then we are grouping it based on the item type. And finally, we are calculating the mean. So let's see what happens. So for the outlet size high, for each item type, these are the mean values for all the numerical columns. When we go to outlet size medium, for each item type, these are the values that are mean. So notice that when we go from one outlet size to another outlet size, the entire list starts again. So all the baking goods till starchy food starts again when you go to the medium outlet size. So you can consider this like a hierarchical group by, where for each outlet size, you want to understand how different types of items are getting sold. So you have the item visibility, mean, item weight, mean, item MRP, mean. But this is too much information. We are only worried about item MRP. And you can just pass item MRP in the square bracket. And for each outlet size, for example, for high, this is the mean price for baking goods, for breads, for breakfast, so on. For medium outlet size, this is the mean price. And for small outlet size, these are the mean price. Now, isn't this a very useful and intuitive way of summarizing your data and performing aggregations? Because using this method, you're actually able to explore the data from different perspectives. Now, whatever we did just now, this is also something that can be done using the pivot table. Now, if you're from the Microsoft Excel background, I'm pretty sure that you're familiar with pivot table. So pivot table is something that's been included in Pandas just to make it easier for those who are coming from MS Excel background. So pivot table is a function in Pandas. You pass the data, you pass the column on which you want to group by your data. For this case, we are saying item type. Then you pass the values column on which you want to perform the aggregation. So the values column is the price, and the aggregation that we want to perform is mean. So mean of price for different item types. This is what we want to do. Let's see. Quickly, we got a result. Isn't this amazing? You're able to do this in a single line of code, and it's very intuitive and very easy to understand. Similarly, the second example that we saw earlier, where we were first grouping based on outlet size, then we are grouping based on item type, and then we were finding the mean of item price. This is something that you can also do with pivot table. You can give a list instead of a column, and let's run this code, and you get the same output. For the outlet size high, these are the records, and this is the mean price. For outlet size medium, these are the records, and you get the idea. So this was pivot table. Now there is another useful function for performing aggregation in pandas, and that is crosstab. Now crosstab is a function that is used to compute a frequency table of two or more factors. Let's see what we mean by that. So we have one factor outlet size and the other factor item type. Let's see what happens when we apply crosstab on that. So what do you see? For each outlet size, high, medium or small, we get the frequency for each item type. So for outlet size high, we have 73 baking goods, we have 25 breads, and we have 13 breakfast items. For outlet size medium, we have baking goods as 203, breads as 83, and breakfast as 36. You get the idea. This is essentially us breaking and slicing the data in different ways so that we get to understand different perspectives on it. And this is what aggregation is all about. Now initially we saw how to use group by and create these hierarchical aggregations. What if you want to add these values to a data frame? So to add these values to a data frame, first of all let's perform the group by again. We want to group by our data based on item identifier, and we just want the item visibility column, and we are going to take mean of that column. So for each item type, I want average item visibility. So this is what we have calculated. For each item type, we have the average item visibility. Now we want to save this in a data frame. Let's see how to do that. In order to achieve this, we simply create a function, and the basic job of this function is, given an item identifier, just give me the mean visibility from this data frame. So that's what this function is doing using the lock utility. Let's just execute this function, and suppose you want to find the average item visibility for DRA24. This is a item identifier. So this is the visibility. You can change this identifier and you will get another visibility. Now we'll just use the apply function of pandas, call this new function get item visibility that we have just created, and for each item identifier we get the average item visibility. So this is something that we have done before. We know we can use apply to call external functions on each record of the data, and we have created external functions before. The only difference here is this function is actually using a data frame to return a value. Pretty straightforward. So let's just run this, and when we check the head of the data, you will see that you have a new column that is average item visibility. Now this task, if you would have noticed, took some time. Now there is a faster way to do this using the transform function of pandas. So you can read more about how transform function works on this link. But just to show you how fast things are, the same thing can be achieved by using transform function like this. It just took that much, that's all. And if you just compare both the item visibilities, they are same. So isn't this amazing? I encourage you to go ahead and read more about transform function from this link. In this video, we are going to see how can you pre-process time series data in Python. So first of all, we are importing two important libraries. First is pandas, and the second is the datetime module of Python standard library. So let's import them. Then we will read a CSV file that has our time series data. So timeseries.csv is the file, and let's see how our data looks like. So these are the first 5 rows of the time series CSV. We have a column date time, we have some count, some ID. Now let's check the data type of all the columns. If you'll come to the date time column, you will notice that the data type by default that's been given to this column is object by pandas. So pandas by default takes date time as a string column. But if you want to work with date time and pre-process this column, you need to convert it to a date time format. In order to do that, we have the toDateTime function in pandas. So it's very straightforward. We say datetime column of data frame is equal to period.toDateTime, the same column. So as you know, it took some time, but let's see what happens now. Now if you will see the data type of the datetime column, you will notice that this time it's datetime only. It's no longer object. So that means we can do further processing on this column and extract features and things like that. So let's see how the column looks like now. So initially our column was like this, and now it looks like this. There's a slight difference, but that doesn't matter. What matters right now is, because we have processed this column as a datetime object, we can do simple stuff like we can just run a apply function on all the values of this column and just say get me the day name, and just doing this we get day name for all the dates in this column. Similarly, you can use the apply function again and just say give me all the month names. So this is how you'll get the month names. Isn't that simple enough? We'll come back to these features once again in the video, but for now let's take another example. So now I'm reading another file which is timeseries2.csv. This is how our data looks like. In this case, the date time column has date given in a different format. So previously this is how our data looked like. Even before processing it, it was almost in the perfect format. But now we actually have dates in a format where the day is a numerical, month name is a short form like AUG August, and the year is a 4-digit number. Let's just see how the entire data set looks like. So yeah, now in order to process this column, this time we cannot just call the toDateTime function on this column. We also need to pass certain directives so that Pandas understands that the format of this date is in this form. Now this is something which we have covered a bit when we were looking at the datetime module of the Python standard library. But for now, let me just remind you, each of these directives have a meaning, and when you give these directives in a format, you basically instruct Pandas or Python that this is the format in which the date is going to come. So in our case, the format is first we have the date as the day number, that is a 2-digit number. So for that we'll use %d, day of the month as a 0 padded decimal number. Then we have the name of the month in a short form manner. So that will be %b, month as locale's abbreviated name. So this is an abbreviated name. It's not a full name like September, right? And then after that we have a 4-digit number describing the year. So this is capital Y, year with century as decimal number. So 2014. So 2000 is the century and 14 is the year. And that's what we have actually given as a parameter to the format option of the toDateTime function. Once you pass this parameter, you can again process this entire column as it is. And let's see what happens after we have processed it. As soon as you process the entire column, you will see that the column itself has become datetime object and entire dates have been converted to a pretty unique datetime format. This is something that we have seen earlier also. Now because of this, you can extract time-based features on this data. So in order to extract time-based features, we are taking the previous data frame that was from the first CSV file. So this is how the data frame looked like. And suppose you want to extract the month number and month name from this date and save it in a new column, you can just do this. Data of month equal to, this is the new column that we are trying to create, data.datetime.dt.month. Similarly, for month name, dt.month name. So let's see what happens when we run this part of code. Now in the new data frame, you have a month column that stores the number of the month, and you have the month name column that stores the full name of the month. If you just remove head from this code, you will see that August is 8, September is 9, and so on. Just like features of month number and month name, you can extract other time-based features like day of the week, day name, day of the year, and so on. So you can just use all the respective functions like day name, day of week, day of year, and you will get a full data frame that is filled up of time-based features. Now this is very important because when we are working with machine learning models in real world, a single datetime object might not be able to tell us as much information as the amount of information we will get by creating these individual features, like whether it's a weekend or not we can get from the day name, whether it's a month that is in a particular season like winters or summers, that is something that we can extract by taking into account the month name or the month number and so on. So you get the idea. Taking a single datetime column, you can actually extract plenty of features like this. Now here is another real world use case. Suppose this is your data frame. So we have the date time column in which some time series dates are stored. Suppose you want to find out how old is this date from today's date. So essentially what you want to do is you want to find the difference between two dates. Well, that is also something that you can do in Pandas. Let's see how to do that. First of all, I'm going to create a new column today, which basically contains the date of today, that is converted to the datetime format using the same toDateTime function. Once I run this line of code and I check my data again, this is the today column. So these are the dates that I have initially in my data frame, and these are today's dates. Now what we want to know is how many days have elapsed since this date to today's date. So first of all, you can just find difference of two dates by just subtracting these two columns as if they are normal numbers. And the reason for that is both of these columns are actually in the pure datetime format. Because of that, you can do things like this. So I'm just finding difference of dates. Let's just print what is the difference of dates. So we have 2762 days, the second date 2761 days and 23 hours, and you get the idea. Now that we have this difference of dates, I'll just run a apply function on it, use lambda construct, and just find the days that have been elapsed, because for now I'm not worried about the hours also, I just want the number of days. So let me just run this. Once you run this, you will only get the number of days that have been elapsed from this date to today's date, and you can just save this entire number of days in a new column, that is day difference. Now if you find the head of the data, you'll see there's a new column that just tells you the number of days that are in difference from this date to today's date. Isn't that something amazing? Now apart from that, another interesting challenge that you face when you're working with time series data is a lot of time in real world scenario, the data that you get is from a different time zone. For example, I'm working in Asia Calcutta time zone, but you might get data that is in, say, Pacific time. So sometimes it's useful to be able to convert this data back to your own time zone, or to convert your time zone to this time zone, so that you can compare dates in the right time zone. You can do the same time zone conversion in Python itself. Let's see how to do that. So the dt.tzLocalize function is actually a function that helps you set the current time zone for your data frame. So for now, I've set the current time zone as Asia Calcutta. So let me just run this piece of code. So this is the current time zone that has been set. Now since I'm using this function on my datetime column itself, what this line of code tells Pandas is basically all of these dates that were present in this column are actually dates of the Asia Calcutta time zone. So treat them as such. That's why when we created a new column, you can see that we also have an added parameter plus 530. So plus 530 is actually the Asia time zone, and 530 is the number of hours that it is ahead from the GMT. So this is how this thing works. Now Pandas knows that whatever date we have in this column is actually of the Asia time zone. Suppose you want to convert this date to UTC time zone. In that case, you just need to call dt.tzConvert function, pass in the time zone you want it to be converted to. For this example, we are converting it to UTC. There can be things like Pacific time, there can be Eastern Daytime, you get the idea. And you just call this function on our Asia time zone column. Once you do that, you will see that in our data set, we have a new column known as UTC time zone, and all the dates have been adjusted according to the time zone. So here it was 25/8/2012, it became 24/8/2012, and this was 00 hours plus 530, this became 1630 hours. So the time got adjusted, and also the day got adjusted a bit, because these are the times after 12, 1, 2, 3, so on. So using these couple of functions, you can actually do a lot of time zone manipulation, so that when you have a data from different time zones or different time sources, you won't end up committing any mistakes. Let's see some examples. So I'm picking a random date. So this is in Asia time zone. It's 25/9/2014, 11 p.m. Now the same date when converted to the UTC time zone becomes 5:30 p.m. So what has happened is the time got adjusted based on the time zone conversion. So this is a very useful utility to have. Apart from this, another challenge that we face when we're dealing with logs and time series data is, in a lot of scenarios, you get time data in the form of Unix timestamp. So let me just show you. There is this file data with timestamp, and if you open this file, you will see instead of having a recognizable date format, it actually has a big number. So this is the way in which Unix based systems like Linux, Unix and Mac store time under the hood. But a lot of times when you're dealing with, say, system log files, you might have timestamps like this. But how will you convert these timestamps to actual dates that are recognizable to the human eye? Well, you can do that also in Pandas. So first of all, when you're converting it to 2 date time format, you give unit equal to seconds and pass the same column. Once you do that, you will notice that Pandas is automatically able to extract proper date time object from these Unix timestamps. So these were a couple of ways in which you can pre-process time series based data in Pandas, and some challenges that I think I faced a lot in my day-to-day work as a data scientist, and I thought it would be better that if you also know about them. Feel free to watch this video again and practice this a lot of times, as many times as you need. Also feel free to use the same code on external time series data. In this module, we will see, given a data set, how can you extract certain patterns or trends by using basic graphs and charts. Now we will be working with two libraries specifically, Matplotlib and Seaborn, both of which are very popular libraries to perform data visualization in Python. In this video, we are going to cover the basics of Matplotlib in Python. So this is how we import Matplotlib. We say import matplotlib.pyplot as PLT. So this way of giving alias to libraries in Python is something that we are already familiar with. So I'm not going to explain this in detail here. Now this is something that we always do when we are using Matplotlib in Jupyter Notebook. This command %matplotlib inline is essentially to make sure that whatever you are creating as visualizations using this library, they are displayed in the Jupyter Notebook itself. So let's load all the libraries and use this line %matplotlib inline. Now if you want to make simple plots in Matplotlib, you can just use the plot function. So I've created two lists, height and weight, and using the plot function we can just pass both the list, height and weight, and we'll get a plot. Note that the first list that we passed actually appears on the x-axis, that is the height, and the second list that we passed actually appears on the y-axis, that is the weight. Now, do you think there is something wrong with this visualization? Well, turns out there is. In this visualization, we are not able to figure out what each of these values on these different axes mean and what this entire visualization is all about. And that's what we are going to learn. How can you add title and labels to your axis? So just run this piece of code. So this is the same visualization, but now we have labeled the y-axis as weight, x-axis as height, and the entire visualization we have given it the title of relationship between height and weight. And in order to do that using code, we did nothing but just adding single line of code. For example, here, in order to add title, we just use the title function of PLT and gave the title. In order to add the x label, we just use the x label function, added the label for the x-axis, that is height, and similarly the y label function for the y-axis. Very straightforward, right? Now suppose I make another plot. In this plot, I've basically plotted two things. The first is the calories burnt, and the second is the weight of the people. Now if you look at this plot, we are not able to understand which of these lines is actually calories burnt and which of these lines is actually weight of a person. And that is something which you can solve by using legends. So in order to add a legend to a data visualization in Matplotlib, you just use the legend function, pass the labels calories burnt and weight, and give the location in which the legend should appear. So when we run this piece of code, the location that I gave was lower right, and that's why the legend appear here. Apart from lower right, you can give other values like upper right, upper left, and so on. Now if you look at the same visualization, you're able to figure out, okay, the yellow line is basically the weight of the person and the blue line is basically the calories burnt. Now in this visualization, we know at y-axis we are plotting the values of calories burned and the weight. But what is at the x-axis? We are essentially trying to plot these values for 4 different person. But if you look at the x-axis and if you look at the visualization, it's not at all obvious. So let's try to fix that. So now what we have done is, we have replaced the default x-axis by label of each point, and each point we have given label P1, P2, P3 and P4 to indicate person 1, person 2, person 3 and person 4. Now this is something that you can do using the xticks function in Matplotlib. The ticks are the location of each tick 0, 1, 2 and 3, and the labels are labels for each tick P1, P2, P3 and P4. Now in Matplotlib, you can also change the size of the figure. So let's see. I have the same code here as we had previously, but now we have made a few changes. Let's see what is the outcome. Now data point for each person on the yellow line is denoted by a star, and the data point for each person on the blue line is denoted by a circle. Also, you will see that the size of the figure just increased. This was the original figure and now this is the new figure. So what have we done here? First of all, in order to increase the size of the figure, you can use the figure function and pass the fixed size. Note that Matplotlib takes size in inches, so 15 by 5 inches. So we have increased the figure size. The next thing that we have done, in order to mark these points, is we have used the marker attribute of the plot function. So here the marker is O, that denotes a circle, and here the marker is asterisk, that denotes a star. Now apart from creating straight lines, you can also create other kind of lines. Let me show you. So blue is a straight line, while yellow is actually a dotted line. So apart from the variables that you want to plot, you can also pass another parameter that indicates the color and the shape of the line. So here Y indicates yellow and dash dash indicates that it's going to be a dotted line. If we change it to something like R, which denotes red, and dash that denotes a straight line, you will see that it becomes a red line. Similarly, you can say G, that denotes a green line, and dash dash again, that denotes a dotted line. So now we have a green dotted line. So this is how you can play around with the kind of lines you can draw in Matplotlib. Apart from all of the amazing features that we have just seen, you can also create multiple plots within the same visualization in Matplotlib. Let's see what do I mean by that. So we have 4 different plots, and calories burnt has been plotted separately, weight has been plotted separately, and you can have multiple things here. So this is something that you can easily achieve in Matplotlib using the subplots function. So in the subplots function, you basically give the number of rows and the number of columns you want. So we have 2 rows and we have 2 columns of our visualization. Then you give the fixed size. This function returns 2 things, figure and axis. Now what axis is? The way you can access each of these plots. So suppose you want to make a plot here. This will be 0, 0, that is 0th row and 0th column. And that's what we have given here. Axis of 0, 0, plot this calories burnt. Similarly, this will be 0, 1, 0th row and first column. This will be 1, 0 and this will be 1, 1. And this is how, using the axis and subplots, you can actually plot each of the individual variables. Apart from this, you can use the same axis to set individual titles, individual xticks, x labels. You get the idea. Now there is something very wrong in this figure, which is, even though we have only 2 data points or variables that we are plotting, we have 4 different subplots. It's kind of looking not good. Apart from that, what you'll notice is the y-axis of both the subplots is actually the same. So let's see how to solve this issue. Let me just run this piece of code. So now we have just 2 subplots for 2 variables that we are trying to plot. Also notice, here we had separate x-axis and y-axis for each plot. Here what we have done is we have same y-axis for both the plots. Now this is something that is just making the diagram look more clean and neat. And the way you can achieve this in code is, first of all, in the subplots we have just added 1 row and 2 columns because that's what we need. Apart from that, the basic thing that we have done is we have said that share x equal to true and share y equal to true. That means just share the y-axis and share the x-axis. And that's why we have a much more better plot. So this was all about basics of Matplotlib, a very useful library. In the next video, we'll see how can you create beautiful charts and visualizations using Matplotlib on a real-world dataset. In the meanwhile, feel free to learn more about subplots from this link. I've also added a couple of links for other concepts in this notebook. Feel free to explore them and their documentation. In this video, we will see how to create basic visualizations using Matplotlib. So first of all, let's load the dataset, that's Big Mat data, and then drop all the missing values. This is how our dataset looks like. So the first kind of visualization that we are going to build is a line chart. We will build this line chart to denote mean price per item. Now the good thing about the plot function of Matplotlib is, by default, if you do not give it any parameters, it builds a line chart. So let's see. First of all, I'm using group by to find mean price per item type. After that, the entire code that I have used is already familiar to you. We generate X and Y. We create a fixed size, we add the title, label, text, and just plot it. So this is how our visualization looks like. Notice that for each item type, we are able to see what's the mean price. Isn't this amazing? Now there is a bit of info about line chart. Line charts are usually preferred when you're working with time series data. So keep that in mind when you're going to use the line chart next. The next thing that we want to visualize is what is the mean sales for each outlet type. And this is something that we can do using the bar plot. So in order to create a bar chart, you just use the bar function of Matplotlib. We do the same thing. We group by outlet size our entire data set, then find the mean of sales. Then we just sort according to the value of sales, create the X and Y, plot it, put the text, put the title, and this is the amazing visualization that we get. Notice that the small outlet size is actually doing more sales on an average than high and the medium size. Isn't that something? The next thing is, how can you build a histogram? So histograms are very common type of plots that are used to see distribution of variables. So suppose we want to see the distribution of the item price. We'll just create a histogram using the plt.hist function, pass in the column on which you want to create the histogram, give the color, give the number of bins, and this is how your histogram looks like. So let's try to just decrease the number of bins. So now we have thicker bins and each bin is representing a range. So bins are essentially increased or decreased if you want to have more granular level inspection of your distribution. So when I say bins equal to 50, I'm able to see at a more granular level how things are changing. The next thing that you want to create using Matplotlib is a box plot. And box plot is something that is used a lot when you want to understand the distribution of a numerical variable. So let's see the distribution of sales. In order to create a box plot, we're using the box plot function. The rest of the code is very similar to how you create Matplotlib visualizations. So notice this box plot is able to tell us things like how many outliers are there in the data, what is the interquartile range, what is the median, and so on. You can also create multiple box plots for different columns of your dataset. Let me show you. So there are two box plots for item weight and item MRP. Isn't that amazing? Now when you talk about box plots, another visualization that comes to mind is violin plots. So violin plots essentially extend over box plots. Let's see what is a violin plot. So these are very similar to box plots, but they also let you feel the distribution of the data at each point. And you can build a violin plot using the violin plot function or Matplotlib. Let's go to scatter plots. Now scatter plots are very useful when you want to see relative distribution of things like item weight and its visibility. Let's see. Notice that you can build a scatter plot using the scatter function of Matplotlib. When you come to scatter plots, the next advanced thing in scatter plots is bubble plots. Now the amazing thing about bubble plots is you can use bubble plots to build visualizations that encode three variables. Let me show you what's happening. So we have three variables. First of all, we are plotting the relationship between the item outlet sales and the item MRP. The third thing is the size of the bubble. Now each bubble has given the size that is equal to the item visibility of that bubble. and we obviously multiply that by 1000 because the item visibility values are very low. But the point is, you are encoding 3 different variables information in a single visualization. So you're able to see the bigger circles represent items that are more visible, and also a lot of bigger circles are in the center area, they're not in the upper right column. That means a lot of bigger circles have medium level of sales. Similarly, you can see a clear pattern between the item MRP and the item outlet sales. Those items which have a low MRP are also responsible for low sales. Now this can be just because the fact that low MRP items, even if sold in a large amount, brings you overall sales amount. But the point is, using things like bubble plot, you're able to do a lot of complex hypothesis testing in your visualization itself. So this was building data visualization with Matplotlib. In this video, we will see some basics of the Seaborn library in Python. So Seaborn, as you know, is actually built on top of Matplotlib. And the biggest selling point of Seaborn is 2 things. First, it builds a lot of beautiful visualizations. Second, because it is built on top of Matplotlib, you are able to do more with less code. So let's see. So first of all, we import Seaborn as SNS. We give some preferences to Seaborn, like set the style as dark grid so that the background becomes really beautiful. We import pandas, import Matplotlib, do the same percentage Matplotlib inline. Let's just run this code. We are loading the same data set, that is Big Mart sales data. The first plot that we want to create is the line plot. Line plot you can create using the line plot function. Give the x-axis, give the y-axis, give the data, and that's how you can get this line plot. As simple as that. Second, if you want to create bar plot, just give the x-axis item type, just give the y-axis item MRP, give the data, you get the bar plot. Now remember, when we were trying to build similar bar plots in Matplotlib, it was taking just so much amount of code. Let me show you. So this is a bar plot that we created, and we had to write this much amount of code in order to create a categorical bar plot. But look at this. We just write one line of code, give the x-axis to be the item type, that is a categorical column, give the y-axis to be the item MRP, that is a numerical column, and we just get a beautiful bar chart just like that. Apart from bar chart, you can also create a histogram using the dispplot function. So this is a histogram. Isn't this amazing? You can also do changes here, like if you just say hist equal to false, it will just give you the distribution. If you remove this, you'll get both the distribution and the histograms. Coming forward to box plot, creating box plot is as simple as one line of code. This is the box plot that we have. Now, what will happen if I change this vertical to horizontal? Let's see. Well, as you might have already predicted, when you converted this to horizontal, we got a horizontal box plot. Going further, you can create Boolean plot by just a call of a function. And Boolean plots are much more beautiful in Seaborn as compared to Matplotlib. Next, suppose you want to create a scatter plot to show relationship between 2 variables, item MRP and item outlet sales. You can just use the rel plot function, say kind equal to scatter, and you get the scatter plot. Now there's another interesting thing that you can do in Seaborn, which is in the rel plot function itself, there is a optional parameter u. U basically means what color you want to give. So let me just plot this. So now I'm encoding 3 different variables in the same visualization. The x-axis is item MRP, the y-axis is the item outlet sales. These circles represent the relationship between these 2 variables, and the color is actually the item type. So the dairy is this color, the soft drinks is this, frozen foods is this. Isn't this amazing? By just using the hue semantic, we are able to encode 3 different variables in a same visualization. We can use the same hue semantic when we are working with line plots. So you have item weight and you have item MRP. You're trying to plot relationship between them, and you can give the hue semantic to highlight different outlet size, medium, high and small. Now once again, I want to remind you that prefer line plot or line chart when you're working with time series based data. Coming back to bubble plot. So the same thing that we did in Matplotlib, you want to create a bubble plot. We use the rel-plot function, give kind equal to scatter, and in size we give the visibility. So let me just plot it. So this is the same bubble plot that we did in Matplotlib, but just see the amount of code that you have to write. Here is just one line of code, and if you go back to Matplotlib, just look at the amount of code that you have to write. Now using rel-plot function, you can also do category-wise subplot. Let's see what is that. So for each category of outlet size, medium, high or small, we have separate visualizations of item weight and item visibility. Isn't this amazing? So this was basics of Seaborn. And in this video, we'll see a couple of charts that Seaborn lets you have for advanced visualizations. So first of all, we have three main subcategories: categorical scatter plots, categorical distribution plots, and categorical estimate plots. For scatter plots, we have strip plot, swarm plot. For distribution, we have box, violin, and boxen. And for categorical estimate plots, we have point plot and bar plot. Let's see what these mean. First of all, let's just see what is the categorical scatter plot. So we give the X as outlet size and Y as item outlet sales. Now this is a categorical column and this is a continuous column. And the kind of plot that we want is a strip plot. So the difference between a strip plot and a basic scatter plot is, in a strip plot, one variable is actually a categorical variable. So in this case, the outlet size is a categorical variable and the item outlet size is actually a continuous variable. So if you want to see the relationship between a continuous variable and a categorical variable, go with strip plot. Now there is another kind of categorical plot that is known as swarm plot. And this plot you can have by just giving kind equal to swarm. The difference between strip plot and swarm plot is, notice here a lot of points are overlapping, right? So swarm plot just deals with that. It's a strip plot, but in this case, all the overlapping points are adjusted so that you get a better view of your data. The next thing that comes is categorical distribution plots. So first of all, let's create categorical box plots. So this is a categorical box plot. X-axis is actually categorical and Y-axis is continuous. So for medium, high and small outlet size, what is the item outlet sales? This is how the distribution looks like. Coming to violin plots, you can just say kind equal to violin in the same cat plot. Here we were saying kind equal to box. So you get the categorical violin plots. Similarly, a new type of plot is boxen plot. So in kind, you just give boxen. The difference between a boxen and a violin and a box plot is, a box plot gives you information about interquartile range and outliers, so on. A violin plot also tries to give you a feel of the distribution of the data at each point. And at the same time, a box plot gives you information about multiple quartiles. So these are all the quartiles if you see, and these are all the quartiles. So you can choose which plot you want based on your requirement. Coming to point plot, you use the same categorical plot function cat plot and give kind equal to point, and you get the point plot. Similarly, if you say kind equal to bar, you'll get the bar plot for categorical data. So for each of the outlet size, medium, small and high, what is the item outlet sales? This is the same visualization that we built in Matplotlib. Let me show you. So this is the same visualization, but just imagine here we had to write like 7-8 lines of code for outlet sales, and here it's just one line of code. That's all. Next we come to density plot. So rather than using a histogram, Seaborn provides you something known as a KDE plot. So KDE is a method for estimating the density of the underlying data. Using KDE plot, you just get a smooth curve which gives you a pretty intuitive idea of how your data is distributed. Similarly, in this case, we have shade equal to true. What if we say shade equal to false? So basically what happened was the shading below the curve just vanished. So shade is something that you can control. Shade equal to true, we get a distribution. Apart from that, we also have the disk plot that we have seen before. So in this disk plot, as you know, you can choose whether you want to have histograms or not by just giving false or true, and you'll get rid of the histograms. Now pair plots is something pretty useful, and this is something that we have already seen when we were discussing basics of Seaborn, but let me just show you again. So we have this data of different types of iris flower, and if we just say pair plot for iris, this is how things look like. Now each of these plots are actually trying to give you relationship with multi-dimensional data. So all the dimensions in your data like sepal length, width, petal length, width, etc. You're able to see how these individual columns interact with one another. So the columns that are at the diagonal basically tell about a single variable like sepal length and the distribution of sepal length for each of the species, Setosa, versicolor and virginica. Similarly, this diagonal element talks about sepal width, this talks about petal length, and this talks about petal width. Apart from the diagonal elements, every other element or visualization talks about two different variables like sepal length and sepal width. How are they distributed for each of the different species of flowers? Sepal length and petal length, and how are they distributed? So this is a very useful way of quickly seeing how your underlying data is set up, and this is what you can do using the pair plot function. So this was the entire data visualization using Matplotlib and Seaborn. Now data visualization is an art, and this is something which we will explore more